make sure we have a recording for this going on so that when we're done with the class, I'll give you links to that too. And it goes up on YouTube on a private channel, an assisted channel. So you can always, dial back into these 2 days and go through it. Now, it's not very, I once it's up there, you're going to have, 6.5 hours each day of video. It's not like it's indexed and you can turn right to where you want to. So, but still, it's still there for future reference. All right. So what we're going to look at here in this in the civil manual is, how this thing is sort of constructed. So if you're looking here on, this is my first table of contents. Let me get to a 2-page spread here. Yeah, so again, each of these things are sort of hyperlinked, or not sort of, they are hyperlinked to jump you to where those things are in the document. Here's a little bit, about me, although I guess this is over 30, is actually now approaching 40. I think next year will be this coming up will mark my 40 years in the industry. So in any case, all of that well and good, but the key takeaway here is this down here: hang on to my email address and use it when you need, if you got any questions that you need to have addressed, that you're if you're running into something that said, gee, how do I do that? Even if it's something we don't go over in a class, once you are an IMSOFT customer, by virtue of the fact that you've, signed up for one of the classes, or whether you buy the software from Mike, I don't do any of this, the sales side, but, by virtue of the fact that you're now an IMSOFT client, then you've got access to me through this as tech support. There's no additional cost for that. But if it's something that, if you get into a situation like, hey, I got this huge project, we got to get it done by next month, I need 8 hours a day of hand holding for 3 weeks, then we talk about a consulting arrangement. But if it's a couple hours here and there, just research a problem, give me a quick answer, then that's all part and parcel of what you've already bought into. So hang on to that. Then the rest of what we're going to be talking about is this upfront information, things like how to organize your work, what's on the menu, blah, blah, blah. All of this kind of stuff down through these, all the way actually through these first 2 pages is really the bulk of what we cover in the fundamentals course of Carlson. We're sort of stepping beyond that a little bit, but we're going to, by necessity, have to spend a little bit of time here to do things like, understanding a couple of settings, what these are going to do for us. And for instance, concepts about points and surfaces. I'm trying to find the app. I keep clicking it. I'm not trying to click it. Maybe I click it up there. There we go. All right. So once we get the surfaces and this terrain modeling starting here on page 18, and this is sort of, we're going to go from 18, 19, 20, 21, 22, 23, 24, and down to halfway down to 25. And that's basically it. That's the bulk of, that's the big knowledge chunk that you want to take away from this, is how surface built, what they're done. So we're going to talk about those. I'm not going to put you through these and let's go here and read this paragraph and learn it, but I'm going to point out a couple of things as we go through this, the key things that you need to remember and keep in mind and sort of internalize. And as we go through these exercises, all of these things will make sense. Okay. So again, we're going to use this as a bit of a structured guide as we go through that. There's a nice little putting it all together workflow exercise here that we may or may not have time to go through. Again, that's usually typically, we're done by the end of the second day in the fundamentals class, but I want to maybe go past some of that. So some of these we might leave to, to leave these to get these on your own, as you work with these. And in fact, as you go to these little red labeled exercises, for instance, it's going to tell you, here's this, step by step, open this file, talk about these points and what you can do with those and how you're going to make that. But this is a nice little, starting from nothing and winding up with, winding up with a, say a stockpile, volume creation, then a little borrow pit, and how, and then once you've got that borrow pit figured out and then merged into that other surface, and then doing a little quick access road to get up and into that, that borrow pit, and these are actually, taken right from the software. These are screenshots from there. Nice stationed roadway, the grading on the outsides coming into this, again, this borrow pit that was sized by knowing how much material you needed to go on a particular project. So it tells you how deep you have to cut that down. So it's a nice little step by step that you go through to get to sort of tie all these concepts together. Now, once we get beyond that point, and that is correspondingly in the table of contents, these are that exercise, putting it all together. So if you go to the next page, it starts this civil module set of exercises, and we talk about roadway design, some grading tools, and then you're going to get into this command reference, two different concepts there. The command reference for the general menus, the file, edit, inquiry, settings, and points, or file, edit, view, draw, inquiry, settings, and points. Those are all the general menus that are on every Carlson module, no matter what it is. And then these are the civil specific menus, 3D data, what they are. And if you go to those, that is just basically a synopsis of what those commands do that are on those menus, how to use them, some examples. And sometimes it's just lifted right out of the help system. Sometimes it's taken from the help system and expanded upon. Sometimes it's taken a very large help system and chopped it down into just what you essentially need to know. But these particular tools, this single roadway design and the grading tools, are really sort of the specifics. Like we look at our roadway design, what do we need in terms of that surface? So we basically are going to tell it this definition of a particular width, a slope away from a reference point, and then a thickness of varying materials, and then how that material gets, handled on the end treatments, curbing, for instance. So we've got tools, and so that will build that all with those individual surfaces. And then let's see, what do we need? So we need a, a center line, a profile, a template or a cross section, and then you process those to generate the geometry, and then you would also want to have an existing ground surface to tie all that stuff into. Now, if you contrast that with this road design that we do here as part of this little exercise here. This is not done using those road tools. This is done just simply using 3D line work. I generated a 3D alignment. I gave it its elevation by having created this three-dimensional road definition. Okay. And then I offset the edges. I went over, whatever that distance is. I don't know. I think it's 20 foot wide. So I went over 10 feet and down at a 2% side slope, set this other edge over here. And then I said, all right, now go out to this existing ground, and wherever this edge is, go at a 2-to-1 or 3-to-1 side slope, whether it's cut or fill, go out and find that existing ground. And that's what generated the edges here. So really, all I did in terms of this road design is create that top surface. There's a case of where if I wanted to, figure out where the bottom of my 8-inch stone layer is, I just basically am going to dial down the top.
Yeah.
In contrast, I've got these civil design tools that are going to actually define these as individual layers, and I can therefore then get individual named surfaces out of there. So you can see if I if I create this top surface, goes from the center of my road, goes to the edge of my gutter, goes to the face of the curb, goes to the top of the curb, goes to the back of the curb, goes to the back of this little, maybe it's a sidewalk or just a little walkway, and then it has the tie slope down to the existing ground. That's that top surface. If I dial that down to get to the bottom of my stone, well, I just take that surface and I just bring it down here. So that means it comes down here, and then it's going to jump. Then it's going to jump up and follow. It's basically going to be exactly parallel to that, but down a distance. And that's obviously not what really happens. There's differences out here on the edges. So, probably more than most, by the way this machinery works, how you would handle those conditions, whether you're just doing a dial down or whether you're going to actually create that other surface and actually grade to that surface as a finished thing. So, and neither approach is wrong, but once you understand that you have these tools that you can get those subtleties, then certainly learn when and where to do the easier things. Sometimes it's easier to just lay down that center line on the ground, offset the edges, and then build a surface from that, and then dial down the subgrades. Or sometimes that, hey, I've got a nice road design, I've got this defined template, that's going to give me a more refined product, I'm going to use those tools. Okay, so that's where we're going to step beyond those fundamental tools and start looking at these civil tools. Now, that's for that road design section. And the other part are these grading tools. And this is basically using this pad, what they call pad polyline tools. We're basically building a pad, although it's not always a closed figure pad. It's basically projecting an edge down to down or up to some target, either elevation targets or to another surface. And that's a really super powerful set of tools, and that's going to be the way you're going to need to start thinking in terms of your edge design. Okay, so when we look at those tools, here's, for instance, we had this roadway, there's our existing ground, there's our center line, and this edges, that's the daylight line of that finished road. Then I've got this little building out here that's going to have this parking lot on the side, and it's going to have a roadway that's going to come back and tie into, let me see if I got a picture of that. Um, but anyway, it basically, this little building design with this parking lot beside it, and then it had a little roadway that went out and tied into this roadway. So how do we set all of those elevations and those tools? And so it's a nice little grading exercise, in particular with this, and this comes from out of that design, this pad template that I was talking about, this design pad, is that here's our building footprint, and it needs to sit on a building pad. That's the outside perimeter. And then that pad sits against that existing ground. And these blue areas are in fill, the red areas are in cut, and that's where it created itself. And then the same thing with the parking lot. It did the same thing, and it's almost entirely in cut until you get to this corner, and it has fill. Now there's two different situations there. So here's the case with the building, and this building pad, it needs to come up to meet the existing ground, and it does, and it did. This went on up and came out to wherever that happened to be. This parking lot did the same thing. It went up, and because it was below the existing ground, it goes up and meets the existing ground. Well, those two edges intersect each other rather, along this line, which you could, essentially throw away the parts that are left over from either surface. But now you need to understand, once you've done that, and that's fine, you could build that, and that would be correct, but it would be like you were going to walk out of this building, you're going to climb up at this 3-to-1 till you get to that edge, and then walk down this 3-to-1 till you get down to the parking lot. But there's no need to have to do that. You could just come to the edge of the parking lot or edge of the pad and just walk straight down to the building. So we need to know that when we get situations like that, that we can go in there and just manually address those particular items. Okay. But the tools will allow us to do multiple pads at the same time, but what it does is it assumes the order in which they're built. Like it would say, construct the parking lot surface first, and then use that as a target to build the building from. And that's why you get that little intersection line. But still, the practicality of this is that's not the way you would normally build that. You would just go from that edge down to that edge, and that would satisfy those conditions that that otherwise targeting the existing ground is going to create. So, and the big tool that we're going to use to be able to do things there, and it's going to give you insights into almost everything else that we're doing as you work, is that 3D viewer, and to know how to manipulate this stuff in 3D and to know what goes into building these surfaces. And that is essentially, it's just looking at 3D data and it's building those surfaces. There's another instance where we had a little bit of a spillover condition, and we would simply, go in there and trim that stuff off. But understanding that approach and what makes these surfaces, to know that we can just go in there and do those trims and tie the elevations back where they're supposed to be, and then go out and build a new surface after we've made those edits to refine that surface, then that's when you really have a good handle on this terrain modeling business. Whereas if you look at everything just from the takeoff approach, just from that typical 3D machine control contractor based approach, they would say, well, I've got a building on this level or on this layer. I've got a building pad on this layer. I've got a parking lot pad on that layer. And I've got all these existing contours out here on these layers. So that's my existing. These are my design layers. Hit the button and say, compute the existing, hit the button and say, compute the design, and bada bing, bada boom, I'm done. Well, it can really mess things up in here, and they're not even aware of it. Okay, now, did that affect how much material they had to buy, what their cost estimate was? Probably not very much, but it wouldn't generate them the detailed nuances that they need in these situations, like here, for instance. It does, however, have some nice tools in that you can give it some dialed in materials, subgrades, and all of that beyond just what the roadway tools do. And we'll take an example and look at some of those things as to what they do. Okay. Let me see here. I may send you some more. Sample data either before we're done or afterward. I have to look and see, because I think I put this data set together thinking that you, and I didn't realize you worked for the manufacturer, and I thought maybe you were just looking at doing it from the contractor standpoint. So it's more of a takeoff approach. And these civil data sets, now you may have everything you need. I think you probably do, but I'll double check that, between sessions. And so I may send you some more stuff that might have some more road building tools in it, but it won't be anything that we'll need for class. It'll just be some follow-up stuff. Okay. So anyway, knowing where we're going to go, we're going to pop back and start looking at those commands. Oh, I did want to show you too the difference here once we get to these command references. When you're using the manual, and after the civil exercises, this is over on page 75, you're going to start these command references in the general menus. And here's the file menus, the first one. A little picture what that looks like, and you'll see the different commands here. All right, and then you'll see some of them that are red and bold, like drawing cleanup. Drawing utilities, audit, etc., is not red and bold. Now, what that simply means is this. If you see that it's red and bold, that means that through my particular years of experience, I have found those to be really good and helpful and productive tools that might be worth taking a look at, because sometimes there are things that we forget about, like on the file menu, the drawing cleanup. We forget about that tool even being there, but there's so many things it can do. So that's all it is. It's just a completely subjective assessment that says, hey, these are cool tools, look a little deeper, and the others are not that way because it might be just, a pedestrian tool, or it's just another way of doing something that something else may handle. Well, that's fine. You may decide that this a temporary erase command, hey, that's the greatest thing since sliced bread, and you're going to use that a lot. Well, that's not to say that that's not an important tool. It's just these are my, this is sort of my history, my experience. So you can sort of, look at that as something that you might want to pay attention to. Now, the other thing to notice about these command references is that, and this talks about here on the edit menu, that it contains both standard CAD editing tools, like move, copy, trim, rotate, and that's just working on CAD geometry, as well as these Carlson enhanced variations on those typical tools. What a guy in one class had years ago, he called them Carlsonifications. And so this is, and this is true about all of this in the command reference, is if you don't see it over here on the side, like this undo, redo, clipboard, erase, select, erase, single, erase, last, the first thing you see is erase by layer. Because all of these other commands are standard CAD commands. So this talks about how these Carlsonifications are what you're going to get here. If it's not listed below, it's just a standard CAD tool and it's not described here. However, it is in the help system in the software itself. Okay. So as we get through that, you'll see those different tools, some different examples about what, uses and how you can use them, what they're useful for. And then once you're through with that on page 90, that's all of those to the point menus. You're going to start to pick up the civil menus, the 3D data, assign, edit elevations, 2D to 3D by surface model, by screen, by start and end. So again, all of these things that are sort of important and helpful, things to take note of. You'll see a little icon here. Let's see. So again, all kinds of ways to do what it is you are doing. Here's a great command: 3D polyline. Make a 3D polyline by a slope on an already existing surface. That's a case of where you can think of it as in terms of, let's say you've got a strip mine or a logging operation or somewhere out up on the like a little top of a mountain or something out in the wooded mountainous part of the wilderness world, and you've got to get whatever you've got on big trucks up there, you've got to get it down and across the valley or down to the wherever the railroad line comes in for you to ship your material to, whatever. You need to build a haul road, and you say, well, I can't, I need to find whatever the pathway is, and I can't go over 8%. That's my maximum grade. Obviously, if you went straight to it, maybe you're going to look at a 15% road grade. You can't go that fast. You got to find that 8% grade line. So that'll basically start at a given point, and it will walk that other surface at a given slope. Now, there's an example.
That's pretty neat.
Yeah, and something like Civil 3D, for instance, the vaunted Civil 3D, that Autodesk and engineers have been clamoring for that capability to Autodesk for years. They say, can you give us this tool? We need to be able to do this tool. And their response has always been to the customers, oh, well, why would you ever want to do that? We don't think you'd ever need that tool. And so they won't give them a tool to do it with. It's not that hard. So but another real simple example of doing that is it came out of a lot of work that we have around here in the shale oil, like this Marcellus, the natural gas stuff that they're with all the fracking and stuff. When they're building these gas well pads, they got these giant well production pads, and they build them out flat, and they've got this real long, say a 3-to-1 fill slope that goes down the valley. Well, to go several hundred feet down that slope, they get at the top, and they've got these berms around the top. Well, they've got to drain the rainfall that comes up there to the top. They've got to get it down the surface of that 3-to-1 fill slope, and they're usually doing that with, say, a ditch, or maybe they're putting in a culvert, some kind of a drain pipe, but they're going to put the pipe or the ditch in, say, at a 5%. Whereas that, let's say it was a 1-to-1 fill slope, that's 45-degree angle up that slide. That's not any 5% slope. So if I start at this point on the top of my fill slope, find me the line that if I walk down that line, I'm going at a 5% grade. So that's what that particular tool that you see here on 104, 3D polyline by slope on a surface, that's what that does. It's super handy and super effective. So, as you go through this and look back on these things, that's what those red things are going to indicate, those particular red tools. Okay. Now, the other part, and again, we'll talk about when we get here, is part of civil, and this is, let's see, we're finishing up which menu are we here? The surface menu. That's where we're going to do most of our actual development work. And then there's another menu here called SiteNet. And this is um, the takeoff equivalent. And there's where we're going to define these layers, surfaces and materials and subgrades with this set the layer target. So right over there on the menu says set the layer target, and then you can display existing, display design, display others. And then you can come down here, you'll make an existing surface, make a design surface, and then you calculate volumes. So that's basically the contractor approach. That's the takeoff approach. And it's certainly available to us in civil, but through a sort of abbreviated command set that's not quite as full as takeoff is, but it's still that same workflow. Okay, so that's there and it's available. And it can be very powerful, in particular with things like this. Here's where I'm defining this based on layers called buildings. And I can include in the material quantities, and I can put in down below here. I've got all these different subgrade names and depths and shrink and swell factors, cost per unit, and whatever the density of the material is. And then we set this up as a library, and then it's going to go through and build. Here's the, say, the existing layers. It creates all of these things. Here's building perimeter, building contour text, whatever layers these might, center line, driveways, whatever layers those might be that define existing design, and everything else is just called others. And so, it keeps track of that. But you'll see when we get to it, and I'll show you some examples with that. And it might be a not necessarily an incorrect way to go, but you need to be very precise with it. You can be, but you can also get sloppy with it and do it basically at the, hey, I need to do a back of the napkin cost estimate because I'm bidding on this job, or I need to get it down to the gnat's eyelash because I got to put it on a dozer and construct it, and I don't want to have to go back and rip out, my edges because I've just done a dial down. All right, so yeah. All of those subtleties when we get to it. Now, that being said, that's the structure of the manual there. The other manual that you have, this takeoff, is a tutorial that steps you through, and this is all that takeoff approach. And again, can be done through the site up tool, the SiteNet tools that you have. Again, you're going to see the style's a bit different because this was put together by Carlson. Come on, let me find example of what I'm looking for. I'm looking for see, they give you, all the different menus. I want to get to the takeoff menu. There we go. So, they're going to get to, there's that examples of the layers. And here's an example of, here's a building pad. It's a layer name that called building pad. And it's going to have, half a foot of concrete, 1 foot of gravel. Those can be done in inches. You can see up here on the depth units up here on the right. So, and they compute costs, and so that can go into the reports. It's not a bad little approach on things. So, and you can even do, shrinkage, etc. To come up with those, but and then it steps you through these like closed areas and how to elevate those edges. And once those are done, now here's the thing about this tutorial is steps you through a very common contractor practice, sets up these edges, defines the material in between them. So it gets good material reports and things like that, but it never addresses tying this back edge back down to the existing ground, because there's excavated side slope out here, either excavated or filled, when this is done. And this entire tutorial, and I've gone through it, Carlson's used that for years, as part of that little demo. There's videos on it on YouTube and all kinds of stuff. But that entire tutorial never addresses things like that. And those are real things. They actually do. You can't go out there and build that and leave the edges up floating in the middle of the air. You've got to tie those things down. So, understand that. And once you understand that concept and the idea of a design pad template, you'll know where to be able to handle that. Okay. So we're going to use these as references and guides. They'll be there to help you out, but we're going to go through a couple of examples and pick up some tools, and hopefully that'll give you something to work on here, pretty, that you can sort of get under your belt and get familiar with. And like I said, keep run through those examples, work on this stuff. If you get to a head scratching mode at some point, pop me an email, give me a phone call. We'll take care of getting you through that, because it does take a little time. You got to go through this until you get that aha moment where you understand everything.
Yeah, for sure.
So that being said, let me show you a couple of other things here. So what you have in your data sets are a couple of things here. This was, again, typically the takeoff data sets. I've got these examples here of some projects that, here's a Family Dollar, South Hills, some kind of self-storage. What is that? The Harmer self-storage, Guardian, different things. And there's these PDF source files that basically came out of construction drawings. There's an existing conditions plan that, for instance, if I were to look at that, this was typically a the plan sheet out of existing conditions this is just a PDF file. And so, using the tools to go through here and elevate these contours, find out what these existing conditions are. And then there was also the design, and this was stuff that all got demolished and a new set of buildings built. And so what that was, this one. Yeah, it was this one. So anyway, using the takeoff approach, we generated a number of different surfaces based on these layers. And you can see this was that existing ground, which had that upper parking lot cut into this building. And some of this stuff is not exactly reflective of what's there. Like, you wouldn't expect to see this parking lot to be sort of, here's the roadway out, the street out here. All of that material had this crown slope in here, was pretty well defined, but once you got into this area, they didn't have any data out here, so there really wasn't any way to do it, figure it out. However, you can see it did have the curbs defined down here on the side. Okay. So, we've got things like that surface. And then when we're building the actual design conditions, you can see that, and this was from that takeoff approach that was layer based, and you could define those. And sorry that it's not very sharp when you zoom in, but it's just a captured view of that surface. But there's actually, this building exists on 2 levels, and there are, you can see that it computes a subgrade adjustment here based on that material thickness. So that basically it says, okay, here's your parking lot, that's asphalt, but under the asphalt is, so many inches of this, and this till you get down to, there's the actual excavated base grade. So, nice little approach, and here it is from just a different angle. And so, we're able to do even that with things like building these little retaining wall edges. Here's some on the side over here as well. So, yeah, and you can do all that with the civil tools. And here's the, say, the finished top surface without the dial down. This is the asphalt. So you've got a little bit of stuff up here, which is the actual curb itself. Whereas before these, you've actually gotten down into the subgrades. So, those are the typical tools. Here's again another example of that retaining wall built over here. There's some inlets built in the parking lot. There's these planter boxes, sidewalk ramps, all those different tools, and then some of the resulting report drawings. Like this is the topsoil replacement topsoil stripping. That's that original, remember, the little elevated parking lot. We need to do any stripping out here because we weren't doing any grading out there. So those were a couple of things, and then how those go into these volume reports. Okay, and different materials all combined. Here's the overall total report, the volumes, materials, adjusted volumes, and then different views. We've been looking at all of these. And those were basically just some reports that I did this particular job for an excavating contractor. And he just basically wanted to get real quick materials so they can bid on the job. And then so the ones that they got, they could then take those surfaces they're already built. They don't have anything to do really. Just go out there and do the work. And so, but those were all taken from, if you look in these data sets and these different examples, you'll see these sources. They were taken from that just flat 2D PDF drawings, elevated into those models, and all of that, the materials, the costs, the quantities, everything that were done, pulled out of those tools, and it was done using that takeoff approach. So even though I've told you about the differences and the fact that you can do things a little more finessed with the civil tools, those site net tools, that takeoff approach, are not necessarily invalid. So just understand the differences and when and where you would use a particular set of tools. Okay.
Yeah.
Now, with that, let's sort of put this in bed. Let me make sure we know some examples. I think getting started is going to be where we're going to do most of our starting work. There's a folder on there called What Not to Do, and that basically has a drawing that this is one I found that Carlson had done, and it's just a AutoCAD drawing file. There's not really much that will guide you here. It's just when I started to do some work with that, I found that Carlson had used this as a little means of trying to show you how to elevate those drawings. And they made some pretty fundamental mistakes when they were putting this together. And they wound up with, this is a case of where, like, if you're looking straight down on something in plain view, it all looks fine, but you look at it in 3 dimensions off to a, isometric view, you can see where things get really screwed up. And that's just sort of a warning to make sure you look at this stuff before you move ahead with it, because I've seen some big dollars spent to fix things that somebody could have known if they'd taken the time to look at it from a different angle. So just not going to be necessarily something you as a manufacturer have to worry about, but your customers will. So just be aware of that. So we'll stick with what we're doing in probably this getting started folder. That's going to be where we'll take most of our work from. Okay.
Yeah.
If those others are there for reference, some may make sense. Some just load them up and look at them and play around with them. Some will be, part of what your book is going to be talking about, but they're going to be mostly from the getting started. All right, now let's go ahead and load up our Carlson software. And again, you're using AutoCAD, right?
Yeah.
Okay, so I'll do the same. We'll say we spent a good hour just talking over what we're going to talk about, and yet there's we need to sort of establish that roadmap, and we're going to something back down here. We're going to spend a little bit of time talking about some settings and what effects they are going to have on our work. So when you start, you either will see this or maybe not, depending on whether you're using the startup wizard. And I'll show you where those are turned on and off. So for now, did you land on this page?
No, mine just opens when it opens and I just say exit, it just opens up a drawing one. And
yeah, so you went to this, I'm going to say basically do a new drawing. That's going to step me through this wizard, and I'm just going to say exit, and bada bing, bada boom, there I am. And it says up here, drawing one. Okay. That's probably what you've got. Like that. It says drawing one up here.
yeah.
Yeah. So it's going to basically dump you into a ready-made drawing. So that's going to start with a drawing template. Now this is all CAD at this point.
Yeah.
So let's take a look at some settings, and we'll see what that's maybe controlling this. Did you also, when you started yours, do you have this tab in the back called Start?
No.
Okay. So that is, I think this will set it. If you go to the settings menu, choose Carlson configure, and then choose general settings. Is this very first checkbox where it says use startup wizard, is that checked or unchecked?
It's checked.
Oh, okay. Cancel that and exit, and right click the mouse and choose options. If that should be the bottom of that menu.
Yeah.
And then if you go to the open and save tab, let's see. Well, let's see. From that, hmm, see if I can find where they may have placed. These are locations. It wouldn't be anything here. Hmm. Well, let's see. There is a command. If you go down to the command line and type start mode, and it's probably set to 0, so you're going to change that to 1.
Yeah, okay, it's set to 0, so go to 1.
Yeah, and now it says you must restart AutoCAD for the Start tab to be displayed. If you are running AutoCAD to a single document mode, the Start tab will be displayed. Yeah, so go ahead and exit all the way out back to the operating system and then come back in. There's, yeah, that's start mode, and that should set that.
So it pops up. This is what it has done before. It just gives me a startup wizard, but it's just like a small
Yeah,
pop-up window that lets you pick the file, maybe a recent file, and then you can browse. But that's all I get when it pops up.
yeah. So if I do start mode, if I set it to, let me see if I can. Replicate what you've got going on here. You get that.
Looks a little different. It's just all it says is startup wizard, and it gives me like my recent gives me like a list of recent projects, and then
Oh, you get the Carlson box from that wizard.
yeah, it has the Carlson emblem on it.
All
Sorry.
right, let me.
Yeah, it does mine doesn't have the AutoCAD, it has the
Yeah,
Carlson.
right here.
Yeah, yep.
Yep. So, and that's okay. That's part of that's the Carlson wizard, and that'll show you some of those same things here too. New, open recent, browse, or exit. Now, the nice thing about this wizard, now that's sort of different from that start tab. So if I, but the difference here is that this is going to step you through a bunch of setup things. I recommend keeping that set to run through when you do get started. But you can also do that from that start tab functionality. Now, if I say exit, it comes back to this. Let me We go back to that start mode. I say 1. And then I'm going to come back into it. I'm going to exit. And now come back. What version of AutoCAD are you running, by the way?
The same as you, that 23.
Okay. So when it starts, you go straight to that startup wizard. You don't get this screen.
Yeah, I don't get that screen.
Huh. Well, I don't know. I don't want to spend a whole lot of class time tracking that down.
No, yeah,
Yeah.
I wouldn't think about it.
Yeah. So, and this basically just gives you some tools to open up existing files, create a new file. So if I go to and this is all driven by AutoCAD. This is not driven by Carlson at this point, but let's say if I'm going to do a new file, and at this point, that's where I pick up here with you. Okay.
Okay. Yeah.
So now, again, you got a list of your recent files up here. You see there's been quite a few in my recent sorted past. Which you can choose from there, or you can choose from these down below. If you say open recent, it's going to go to a folder. So, oh, it goes to the file that I was working on, one called Scribbles. No, that makes sense. All right. Let me back out of here. I go to new again this time instead of open recents because I was sitting on that file name Scribbles. So now it's going to have me go through these wizards. I'm doing a new one, and this is what the wizard is going to do. It's going to prompt me through a series of steps. So if you need to go ahead and start a new drawing and go into that, in fact, let's do this. I'm going to exit all the way out. Come back to here and let me see if I can. So, I want to get all the way back here. Let's just do this. I want you to get to that very first startup wizard, like so you can follow exactly what I'm doing. And if you need to go back out and back in, go ahead and do so. So when this does come up to me, I'm going to get here. I'm going to say new, and that should kick me into that. There we go. Tell me when you get to this point.
Okay.
All right. So now from here, we're actually in Carlson's control. This is their startup wizard. And we're going to choose this new button at the bottom, and that's going to kick us into these other tools, right? Enter loads up a bunch of stuff that I've got set up interface wise. It's going to give us to this choice at this point is to select a template. You get to that point?
Yeah.
Okay, so are you familiar with what a drawing template is?
Yes. Yeah.
Okay, so that's basically, where you've set a bunch of predetermined things that there are settings that apply to AutoCAD in general. Once you set them, they'll stay with AutoCAD no matter what file you're working on. There are other settings that stay with the file, things like the layers that you find, the line styles, the text styles, the anything that you pre-draw, you can use that as a starting point. So This is simply letting you choose that drawing template. It doesn't really matter. It's just something that helps save you some work if you have to go and do some setup later on.
Yeah.
So,
Now, question for you. I'm adding, so like we have a layer library, right, that we add in.
okay.
Can I add that into a template off the beginning, or do I have to every time go into settings and then
No,
add library?
no, you can absolutely add it to your template, save it, and then you don't have to do it from that point
Okay.
if you start with that template. Okay.
Yeah.
But, and that's a, you know, that's a good illustration of using templates effectively.
Yeah, that's what I do in Trimble, and I
Yeah. And the fact that you're able to do layer libraries though as a separate step, you know, that's also some added functionality, just another way around to it. So
yeah.
and you know, none of these, and you can see sometimes the template has things pre-drawn in it. These have like title blocks.
Yeah.
Here's a civil demo. I don't, that was made from something else. Carlson, National CAD standards, civil, the ISO, civil 3 or AutoCAD 3D, AutoCAD standard named plus, you know, so there's all kinds of potentials. It's usually going to be one that you choose. So I don't particularly care which one you want to use. I'll go ahead and use this Carlson 23 just to get things started. I'll say, okay. And you see, and it's pretty light as to what's in it. Probably these layers are going to be all that's there. Now, the next part of our wizard, you notice there's this little checkbox in the lower left.
Well, hold on, Ken, 1 second. So under templates, okay, here we go. So I only have
Yeah, just you can just pick one at random. I don't really care which one you use. I just want you to understand what they're used for. And you know, you're gonna set that up. You know, in time, you're going to get to a point where, you know, I'm really tired of I'm really tired of having to do this every time I start a new drawing. And you're gonna, that'd make a good candidate for something to put in my drawing template. So your drawing template is going to evolve. And
yeah.
you know, so right now for what we're doing, it doesn't make any difference. Just choose one and go. And then let me know when you get to this screen here.
Yeah, I'm there.
Okay. So now what this is doing, again, if you look in the lower left, there's a little checkbox that says skip the startup wizard next time. That turns all this off so that you don't have to go through it if you don't want to. Some people don't like going through this and they want to do everything as they start up a new one. Sometimes they don't ever start a new one. They'll start an old one. They'll open an old one and then do a save as, and that's perfectly fine. There's a little bit of a risk there that you forget to do save as and you overwrite what the old one was. You know, so I like to use it because it has a couple of safeguards in it. I'll show you how these help you. But everything that you're going to do in this wizard and any other wizard is doable by individual commands as well.
Yeah.
Okay, they don't, the wizard is nothing special other than it strings together a bunch of individual commands so you don't have to go through and do them individually. So we're going to look at this and look at our scale settings. And let's talk about what that means in terms of Carlson. Because as you're probably familiar, the drawing itself is going to be not drawn at scale. It's going to be drawn at, you know, real dimensions. If I need a line that's 50 feet long, I'm going to make it 50 units long. I'm not going to make it 5 units long and say, hey, I'm at 1 inch equals 10 feet.
Yeah.
So that really only applies when I go to plot these drawings. And that's the same thing that's going on here, is when we set this scale value, we're telling it that, at least for now, what I'm anticipating is that I'm going to be plotting this stuff at a 1 inch equals 30 feet scale. And, that might make a difference. I've got a surveyor client who he deals in like multi-thousand acre tracts all the time. So he's plotting things at 1 inch equals 200, 1 inch equals 500, all of that. And so when he generates points and labels and stuff, he has to make his text really big in terms of the ground units that the text covers, so that you can see it when it's plotted. And so that's what this is doing here, is it's basically coming up with the means of generating text and symbols at a particular size when you plot it. So if you look up here, and we've chosen English units, 1 inch equals question mark feet, that means this number. So 1 inch equals 30 feet. And there's symbol plot size and text plot size. And that's sort of a trigger word there. When you see the words plot size, sometimes you'll see symbol size scalar, SCALER, meaning it's going to multiply that number by the scale value. And so what this allows us to do is that if we decide most of our drawing stuff, we want our symbols to be a particular plotted inches. If you think of this field right here, the symbol plot size and text plot size as your plotted inches at whatever scale, then you never have to change these values, or they can stay set no matter what scale you're at, and it will recompute. So here it is. If I want symbols to be 1/10 of an inch, and if I'm at a horizontal scale of 1 inch equals 30 feet, that means my drawing units, my symbols are going to be 3 feet tall. So if I make this, instead of 30, if I make it 50, I'm going to say 1 inch equals 50 feet. Notice how these numbers over here change for us automatically. So, we used to, if we're not using something like this, we would have to figure out, what size, and we tell, and these numbers over here, by the way, are the numbers that AutoCAD uses when it creates symbols and text. AutoCAD knows nothing about this over here. Carlson is taking these numbers that it gets from us, and it's giving these numbers to AutoCAD behind the scenes to generate those. Okay, so
Gotcha.
that's what this mechanism is doing. So I'm going to put that back at 30 feet. And now the coordinate system. Typically, nowadays in particular, that we're using GPS a lot, we're going to be in a particular state plane zone, and you can choose the different definitions, and you can get into the geodesy of all of this, and you can come up with a user defined, and all these really weird things, but you're going to most likely be using state plane 83, at least for the moment. And you're what, in Chicago?
I'm actually in Texas now, like just outside.
Just outside where? Outside Dallas?
Yeah, Weatherford area.
Wow. Okay. Well, I started my career actually down in Houston for
Okay.
a big company then, and this was back in 84. The company was called ServCon. They were part of Turner Colley and Braden, which I think has now all been, they were part of this big buy-up. Forget who did it. It was not Prime AE. It was like, it's one of those big multinational. Anyway, I forget who it is now. But and we had a Dallas office. We were headquartered in Houston. That's where I started, but I worked out of the Dallas office for a big project that we did down there. And we We were located over on Josie Lane. I think Josie was the north-south road. It might have been the east-west road. I can't remember now, but it was on the west side of the city. Right as you came in, I landed out at DFW and then drove in. I never really got into downtown Dallas.
Hmm.
It was out. Yeah, it doesn't matter. It's been a long time ago. Okay, so you're in. You would choose. Whatever your corresponding Texas stuff is here. For us right now, it's not going to matter.
Yeah.
Because we're going to deal with just assumed coordinates at this point. But some of these, I'll have you set them to match Pennsylvania South because they're taken from our local areas, and you'll see how we can use that to overlay aerial imagery and that sort of stuff. And then the lat long datum is typically if you get things that are GPS origin, that's going to be this World Geodetic System of 1984. Which is mathematically equivalent to national or North American datum of 1983. There are some subtle differences. Leaving that default should be fine. This project name, location, job number, these are just text fields that will show up on your job reports and any of your listings like that. So if that's important for you to keep track of those, you can fill those out. You don't need to. And then we're going to hit the next button and you're going to see what happened. This is why I like the wizard. He goes, "Hey, dummy, you forgot to put the drawing name in." Okay. And that's way up here at the top. And it's very easy to overlook because I started right in here, remember?
Yeah.
So we have to give it a name. Now, we can just type a name, and wherever it's going to place it, what folder it's going to place it in is going to be based on another configuration that we do. But if we hit the set button over here to the right, that lets us find the location that we're going to put it. And it starts me off here in Carlson projects. That's again based on the setting. And I've got over here in this subfolders window on the right, these are my subfolders that are in Carlson projects. And I'm going to go to this one here that I've already made for today's class called 3D Machine Control class. I'll double click that. And it has a subfolder called data sets. I'll double click that. And so I can do this. Now, this is the Carlson dialog. And I'm going to show you, and you got go up a level, select different folders. You got all kinds of controls here. And there's what I want to point out is the difference between this dialog and the Windows dialog or the AutoCAD dialog and some of the similarities. So you got some of these different controls here, like go up a level. You can use a currently selected folder as the data folder. You've got these create a new folder, remove, rename, different controls that you typically have slightly differently in the Windows side. But one of the nice things about this when you're working with certain file types, because you'll get this anytime you need to open or save a file, you'll get this tab. Sometimes you'll get this dialog. And sometimes the dialog will have two tabs at the top, one that says new and one that says existing. And sometimes even a third one, which will give you the option to append an existing file. But the nice thing about this dialog box is a couple of things. If you look in the upper left or the top stripe here where it says drawing to create, and it gives you parentheses DWG, that tells you the extension. That's basically in the Windows dialog. And if you hit this browse button, that puts you in that Windows dialog. That up here where it says DWG, that's this save as type. That's where it's getting that from. Okay. Now, there's no reason that you can't always hit that browse button and go straight to this. That's perfectly fine. If you're more comfortable with that, that's absolutely fine. But what this also does, if I can get this to stay on top here, what this dialogue actually also does, I don't know why it keeps jumping here. Well, let me just drag it over here enough to get it out of the way. Is it shows you whatever you're in, whatever folder. Let's say I go down to here, and it shows you in this part of the dialog here, this current folder files, that shows you the files that are in that particular folder. And if I go down here to my getting started, you see, these are the files that are in that folder. Now, you're going to see possibly some of these files that have a period as the first character. You can ignore and even go in later and safely erase those files. Those are some little leftover things that are, that happens because this was all produced on a Macintosh. And so you've got all of those are called resource forks. Notice they're all the same size. Those are things you don't need for the Windows side. So anyway, it shows you all these different files. Now, these are existing files. If I were to choose one, it's going to complain and say, hey, you're getting ready to overwrite this file. So I don't want to do that. I could just type a name up here. But it also gives you down here below a list of recent files, no matter what folder you're in. So see, here's one called Scribbles that was in this folder. Here's one called the Updated NPDES Plan 2023 that's in this other folder, you know, wherever they happen to be. And these are just recent files that you've done. But the other nice thing on this, also again up here, it shows you the file types, is you'll see, depending on what it's asking for, sometimes a little graphic preview of the files you select. It doesn't do that with drawing files, but it does with surfaces and coordinate files and such like that. So you can sort of get a sense to make sure that's the file you want. So it's nice. I think I've gotten used to it. It gives you some additional tools that you don't always see with the Windows dialog. So whatever way you're going to work here is fine. So I'm going to pop back out here to my Windows directory. Like I said, it's fine to do it there. I'm in this getting started folder that was part of my working set, my data sets, and in getting started folder. So that's where I am now. And I'm just going to call this one starting file 1. Okay, and I'm going to hit save. All right, so now that comes back and it puts you back in here after you've hit browse and hit OK. It puts you back in Carlson's dialog, at which point you've given it a file name, you've told it where to put it, and now you hit the open button down below, and that will dismiss. And I've gotten out of sequence here. Let me see here. All right, my new drawing name. Let's try this one more time. All right, so I'm in my 3D machine control class, my data sets, working, and I called that not working, getting started, sorry. And I called that my
starting file 1, I think.
File 1. There we go. So now that puts in our file name up here. And now when I say next, it's going to allow me to go on because I've now told it the file. So it's going to go to the next step with it. All right, so now this lets you set the data path. And right now it is set up to, and I'll show you where we change that in a minute, where our data is going to go. It's going to go in this folder called Getting Started. All of the files that we create, all the center lines, the coordinate files, the profiles, the surfaces, everything will go in this folder. I can change that folder if I want. it just gives me this option. It will default to where we've set the drawing. And that's also, again, based on a setting. And the next thing down is going to ask for a coordinate file. Now, coordinate files are files of those Carlson points. And you could have one, you don't have to have one. You can actually work with drawing files without using a coordinate file at all. But it starts you off with letting you choose one as a new file, and it can just stay empty, or it can be an existing coordinate file if you're working with something that's already been collected and turned into a Carlson CRD file, in which case it's default setting to existing. I'm going to change that to new. Let's just do a new file. And also by default, again with the set button, it's going to name that file the same name as the drawing file. It doesn't have to be. And it's going to be in that same data path folder that's set up here. And then it lets you import points into this new file if that's what you're doing, or even into an existing file if you've chosen that. But into whichever file this is pointing to, you can import points from these different sources, either from a data collector, and that goes into that little link up where you can connect the data collector and you can pull it all in. All of these things can be done individually, and that's what we're going to do. Is we're going to say no import, just a new empty file, no import. We're going to keep it empty, and we just say none, or I'm sorry, next. And then that's going to put us out into our drawing. Now, what has been set for us in that drawing? If I look at my layers, and if you don't have your layers box open, go to your view layer control, and that will bring up your layers dialog. And so it's going to be whatever layers were defined in that startup drawing template. Okay, and yours may or may not match this. And I'm going to double click that and set on my existing layer. Again, doesn't matter. But that's what's set there. Now this layer, are you familiar with these, how to float these palettes and make them disappear and all that?
Yeah.
Okay, so that's all I've got. And I just keep that over here and float it all the time, just, and it's sort of hanging out over here over top of my properties dialog, which I've also got open, and I dock it, but I don't auto hide it. I just keep it open all the time because I use it quite a lot. I also have over here on the right-hand side, my XREF manager.
Yeah.
So, and again, you know, it's whatever you want to do there, and whatever toolbars and such that you have open that you want to work with. But I find it very helpful to have properties docked, whichever side, wherever you want to go to it. And I have certain toolbars out here that you see. Mostly Carlson. There are some AutoCAD, like here's an AutoCAD draw toolbar. This is a Carlson draw toolbar. I've got on the right my AutoCAD modify toolbar. And I've got up here at the top, say this Carlson surface toolbar. Here's my standard annotation toolbar. I've got up here my and I'm just pointing to these little, you see that little sort of looks like a double dash line. I hover over that and it's telling me that's my Carlson layers toolbar. Here's my polylines toolbar. So different things that I've found useful. Now, if we get into where we're going to need that a lot, I'll show you which ones that might be helpful to have up there. There's certain things like, here's a command I use quite a lot. This remove polyline segment and remove polyline vertex. Now they're just really handy. Now, I know what the icons look like. I know where the commands are on the toolbar. It's really handy to get there because it's a good command. And if I want to run it as a command, I have to go to Edit, Polyline Utilities.
Yeah.
And then come down here and find the remove polyline functions and then remove polyline vertex. So there it is. You know, click, 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 click. and finally I get to it. Otherwise, I can find it on the toolbar. Now, here's something also to know about the software. When you look at these menus, notice that some of these commands have icons to the left of them.
Yeah.
Some do not. The ones that do, what that's telling you is that that is a command that is available on a toolbar somewhere. It doesn't tell you which toolbar, but it does at least show you that it is available. And another couple of things when you look at these commands, if I go to well, of course, it's not going to show me on that one. Let's see if I can find. I may have a setting turned off. Normally, it will show you down here on the status bar. It will show you what that command does. Apparently, all right, so this is the difference between this and the IntelliCAD. IntelliCAD, it would show you down here the typed name of the command. Up here, when you hover, at least on some, it shows you what it does. Freezes layer by picking any entity on that layer, colon, and then PICKOFF. That's the typed command. And then you can press F1 for more help, in which case, that would bring this up, and it would supposed to go to that, which it didn't. Let's see, this one, triangulate contour, press F1. All right, so that doesn't link very well to that. And so that should have done this. It should have linked into this help. General commands, let's see, edit. So if I remove polyline vertex, for instance. All right, so when you do drill down, and those are supposed to be context sensitive, the IntelliCAD, at least when you choose those extra help things, they go right straight to it. And I'll show you where these are also, they are hyperlinked correctly from the dialog boxes, I believe. But it puts you into the Carlson help system, but it tells you down here what menu it's located on. So this would be under edit, polyline utilities, remove polyline. This is the typed command. But again, it doesn't tell you what toolbar it's on. Okay, so that's something you have to sort of glean out on your own. So if we were to do something, say, I'm going to do a triangulate and contour bit, and now if I choose help from here, that's going to go to the Carlson. So that one is linked correctly. Okay, so just understand that. So when I get that other thing, now if I do an erase, let's do erase. Well, I'm not getting, I need to find. I need to find a standard CAD command. Let's see, this is save, press F1. So see, that actually does link to the right AutoCAD. When you get that little floating box and you press F1, that will link you to that particular command in AutoCAD if it's an AutoCAD command. Something like this, you do that, and it's trying to link you to that, but there's not a, it's not a AutoCAD command. That's a Carlson command, so you won't find that one in that linking. So it's a little bit of a disconnect. So don't don't dwell a whole lot on that, but you can find those. And anything that you're doing under your Carlson help, these are all done by the different, here's your general commands, those menus file through points. And then you've got the different modules. So you've got civil. So these would, all of those different menus and all those different commands are on those menus. Okay. Now, one other quick thing. When you're learning this, if you look under the Carlson Help System, there's a section down here at the bottom called tutorials. And these are some really good, sometimes they're very basic, but good little things to go through here. And sometimes they won't matter, they won't make any sense for you. Like there's some mining stuff down here. There's takeoff and site net. That's that tutorial, that takeoff tutorial you've got the manual for. And that basically steps you through. There's that file that we talked about, and that steps you through that whole process. Okay, so some nice little things to go through, but the big one here that you want to do is called this a dozen tools for surface design. So these are all these different kind of things that you're going to typically do to help you develop surfaces. Some of which are good, some of which are not so good in my opinion, because they're telling you to, you know, make existing surfaces from drawn contours. And sometimes that's all you have and that's all you can do, but that's really the worst possible source to develop a surface from, because contours are really the output of a surface. They should not be input.
That's a brutal battle right there.
Yep. And so, you know, that's where you got to know and how to deal with that. So we're gonna see some tools and some techniques that are going to help us get past that, because again, sometimes it's all you have and that's all you can start with.
Yeah, it's typically all we get on our end.
Yeah. And so so there's some things to help with that. And we'll see that as we start to go through this. All right. So yeah. So don't lose track of that particular thing down here. That's
a good I'm, you know what, I've searched a lot of stuff and kind of like I got a help book that I kind of look at, but I haven't got into this Carlson help guide.
Yeah.
Really.
Yeah.
It's really, information.
It's really kind of nice. And there's also under here, you've probably done this one where you've looked at these online training movies.
Yeah, a little bit.
And those are good in this sense, because it puts you into their basically their YouTube channel, and you've got them all by different categories and, you know, different ways you can search through, and we won't go through them, but they tell you, you know, how long the videos are. Here's some advanced point cloud stuff, working with PDF, and, you know, so, and these, there's a number of here that you're going to see these things called power tools. And they're done. That guy that you see there in that little talking head down below, that's Gary Rosen. He's up in the Boston office, good friend of mine. He's really good at sort of putting together these little half-hour sessions that shows you some of these tools, and they're just like a one specific, or maybe he'll go through a, you know, a series of like, down here's 10 surface modeling power tools. Nice little concise 10-minute video that shows you a couple of things that you might can do. They're not comprehensive, but they are focused. So they're good to look at. Some of these, again, keeping in mind that they're done by programmers and demo operators, not necessarily practitioners out in the field. But you know, it's a good resource. So use them as you need. Now, we're going to take a little break here in a second. And I know we're about half hour past where we should be breaking, but we'll go ahead and get a break in. So what we're going to look at next to get some of these things started is we need to take a look at our settings, and we're going to go to the settings and Carlson configure. And right in here's all of these different settings, and I'm going to show you the ones that we need to set up and how they're going to behave and how they're going to make our system behave and what effects they're going to have. And we'll take a look at those when we come back.
Perfect.
So some of these we don't need to worry about. Some of them we can set once and forget, and the others are going to be that you're going to change them as you need as you work with a particular set of drawings. Okay, so we'll come up there. We'll go ahead and take a break. It's almost 11. Let's start back at 11:15. That'll give you a chance to stretch your legs, get a cup of coffee, take a few phone calls, and we'll pick up from there and go ahead. Now you are what, 2 hours? You're at 9 o'clock or 10?
I'm at 10.
You're at 10. You're
hour behind you.
Yeah. So you'll get an early lunch today. That means you start at 8. Is that an okay start time for you? Do you need to adjust that or anything?
It's fine for me. I'm still kind of working in the back, on before and after. So it's fine. If you want to start a little earlier,
No,
earlier.
Yeah, these are fine by me. 9 to 4:30 is a good shot for me in terms of my schedule.
No, it works perfect for me. It gives me a little bit of time in the morning and get some stuff. So.
All right. Well, we'll call a break there. We'll start back up at 1/4 after the hour.
Okay.
I will, at this point, I'm going to pause our recording and we'll resume that when we come back. Now, what I'll do is I'm going to go ahead and we'll go from there. All right. So first of all, any questions occur to you over the break that you have any question on?
No, I'm excited to go through these settings. I think that'll kind of help out a lot of little issues I'm coming across too. So I'm excited for that.
Yeah, okay, great. So let's explore those. Let's look under our settings commands. We'll go to our settings menu and choose and you see these things like set the project data folders. Now you can do all that from within this Carlson configure as well. So let's look at the Carlson configure and go through a couple of things here. Now we have some things down here below like localization settings. And if you look at those, that is just like where you can set particular language localizations and set particular default values that go into those individual localizations. If I always point out to my surveyors, that's not the same thing as doing what's called point localization for GPS equipment. That's a completely different thing. So that's something you probably never even need to look at. The takeoff SiteNet settings, if you look at that, this is something that if you're doing your surface modeling using the SiteNet tools, or if you're running takeoff, these are some things here to deal with. And we won't really work on this here. I'll show you when we look at the SiteNet tools what these are going to do for us. But for now, you can ignore those since you're going to be dealing mostly with the civil type tools. Okay. Mining and my notes, no need to worry with those. Hydrology, same type things. You can look at those. They're settings on how you set up your pipe stuff. And if you don't have the hydrology module, that won't make any difference. Section and profile. If you look at that, that lets you pre-build default eye height and object height for your stopping sight distances and all that kind of stuff and what station types. The defaults are fine for that. And again, all of these are just default values. You can change them individually as you go through commands if you need to. And you can see there. So then let's look next at the survey settings. And again, it won't make any difference. You don't have the survey module, but these are things that they would, again, turn on some default behavior. So no need for that on ours as well. And then the surface settings, if you look at that, and this is mostly for when you're doing grid file modeling as opposed to triangulation. We're going to 99.99% of the time do triangulation. So these don't have much impact on what you're dealing with here. But a couple things that you might want to set is down here on the bottom. You want to track your tin history, include your detailed source data, and track surface data changes. That allows you to roll back individual surface file edits that you may have made. Now,
Okay.
this is a relatively new set of settings. It's something that I never really use because I'm not a big proponent of building a surface and then going and doing direct edits on the tin itself. Although you're certainly able to do so, I like to go back and fix the data that caused the problem in the first place and rebuild the surface. Because to me, I am then starting with the proper data and I don't ever have to worry about reproducing those edits later. But
yeah, I agree with you.
for those that do those types of things, it's good to have those on. And it doesn't hurt to have them on anyway. So I would turn those on or not. And then that should be that for that. Now, the remaining 4 buttons are going to be some things we're going to take a look at. These 2 on this side, the startup and drawing setup, and well, even this one, the project data folder, these are going to be sort of set and forget. Let's look at the startup settings first. And this lets you choose a default starting drawing template. So if you have one, you can hit the browse button and point to wherever it lives that you want to start with, okay, by default. And it can be anything you choose. And again, you notice in the wizard, you can choose a different one as you start up anyway, but this is going to be one that's pre-selected. And then what folder you want to start in when you start working on, particularly with new files, this is where it's going to start you out, and then you choose from there. The profile name, this is the actual AutoCAD profile, and that's generally just leave that as it is. But if you get into some profile modifications, you can save it under a different name and start up with a different profile. The command switch, no logo, and then the AutoCAD product to run, all of that gets set when you install the product, whether you want to skip the splash screen or not. And no menu resetting. Keeps Carlson as partial menu. I would leave that unchecked. Otherwise, it keeps these tools left in as partials. As you'll have one that just says Carlson, and it puts all of these menus under a sub menu if you switch out to the AutoCAD menu. But usually I would leave that unchecked, because when you switch over to AutoCAD directly, it switches menus, and you can then switch back at another time. So that's you know, a set and forget type of thing. Okay, so it tells you that it updated those. And let's look at the project data folders next. Now, this is, and again, if we look in our book here for a minute, organizing your work. This is what it's talking about here, that there's this directory structure, okay? And there's 3 different models. If you look at this dialog that we have open now, you've got a project folder, a drawing folder, and a fixed folder model. And what that means is, if we're using the drawing folder, notice all this other stuff is sort of grayed out except for the startup, which again, we just set another place. You can reassign, you know, where the data folder lives. Carlson products, the startup project / data folder is going to start you there. But what this means when you say drawing folder, that means that your dependent files, your surface files, your alignment, your coordinate files, all of that kind of stuff are all going to go in the same folder. By default, they're all going to go in the same folder that your drawing is in. So once you've created the drawing and assigned it to a folder, that's where everything is going to start to look for those files and start in that folder when you save those files. Okay, and then use a data folder for settings. This down here at the bottom, there are certain settings when you set up a bunch of things in a dialog, you can save those settings, and by default, they're going to go to, now I've got this set to 2022 AutoCAD. Let me see if I haven't updated that. I don't know that I've hadn't created one yet for 2023. So I can set here in Carlson projects, what did I call that? Settings dash 2023. So I say Carlson projects. I'll make a new folder. I'll call that one settings dash 2023 ACAD. Now, what that means is, and I'm going to choose that as that folder. And now I'm going to set my current to that same folder. So what that means is anything, if I save my settings from within this session that I'm running here, it's going to go into that folder. And those are going to be sort of global settings that I want to use. Maybe I'm working on a particular type job for a DOT, and I might save those settings, you know, my station, my stationing values, and that's settings like what layer they go on, what text style, sizes, the format of the stationing, or maybe a surface generation, like go to every 2-foot contour interval. You know, all of those different things, I can save them, and by default, that's going to be where it's going to offer to save them. You can always, at the time, you can navigate away from that folder and set them in a different location, but this is just setting up a default. Okay, now the other two options, this one that says fixed folder, this now opens up this current data folder field, and it lets you set a particular fixed folder that all of these dependent files are going to go in by default. Now that used to be the way Carlson worked back in the 80s, that it all went into a folder called SCAD, which stood for ServCAD, which was what the product was called then. It went in a folder called SCAD data. Everything, no matter what job you're working on, that's where it went. So now we have the flexibility of staying with our drawing. And this is what we're going to use for what we're doing now for our training. And that's the simplest. Everything stays with that particular one job. The other option is here under this project folder. And if you look back here in this, you can see show this picture, is it lets you build, if you choose this project folder and then you set this project folder setup, it lets you build a list of folders from whatever the project is, and that's just a placeholder, and you would name that a particular project. It's going to create all of these different subfolders, your choice of what you put in there. And then you're going to assign with this data type subfolders where those go. And here's the way that's going to work. So this project folder, if I choose that and I choose this project subfolder setup. Now you may not have anything defined on yours, but this lets you, in this particular case, this was the last one I've used. I've got a, whatever my project name is, then I've got a data folder, and I've got an other folder. And so underneath that, under data, I'm going to put alignments and profiles. I've got points, I've got surfaces, and then I've got drawing files. And again, that's at the same level as my data. So I've got a project, whatever my project name is, I've got a data folder, I've got a drawing files, and I've got an other, and I've got things like deliverables, PDFs, you know, you might have contract information. anything you want, you can create. Okay. And then once you've done that, you look at this data type subfolders, and here's a nice little trick to recall to help you out here as you work. Even if you're working on this model, which we're going to be doing, if you need to find out a particular bit of information, this is handy. You can switch it here temporarily while you're here in this data type subfolders.
Mm-hmm.
And this is going to open up this list of all of the different data types, which in this particular build, I've got 271 different file types that it's going to create, possibly.
Mm-hmm.
So if you see a file in your folders, let's look back over here for a minute. Let me go back to this. Let's say we scroll down here and I see a file. Here's one called .tpl. Well, what's a .tpl file? I don't know what that is. Well, you can go over here, set that temporarily to project folder, hit this data type subfolder, and now you scroll down here till you find this .tpl. And I look over here. Oh, that's a template. Okay. If you don't know what a CRD file is, we can scroll up here. And these sort, by the way, based on clicking these things, it will sort those. So here's a CRD file. Let me find the CRD. And I say, oh, that's a coordinate file, whereas a CRB is a curb template.
Hmm.
So it's handy in the sense that it lets you know what those are. But let's say you are using that folder structure, and anytime you start a new project, for instance, it creates all those folders, and then you can assign based on, you know, these different modules or by all categories. Let's say here's our civil types, here's our civil survey types. So different things, like here's a centerline, for instance, a centerline file, and that I'm going to assign that. I pull this down, and instead of going at the project level, I want to go to project data, alignments, and profiles. That's where I want my centerlines to go in. My template curves, I might want to put that in maybe program settings, or maybe since it's a curve, maybe also put that there. Coordinate files, I would put that, say, in data points. DWG, I don't see my drawing files. I assign that separately when I'm doing. Here's my horizontal speed tables, for instance. I might put those in settings. So anyway, you basically assign these different folder types to these subfolders. And again, all you're doing is setting the default locations, which you can always navigate away from anytime you need, but it lets you, you know, control where these things start looking for those particular file types. Okay.
Gotcha.
And if it just says project, then that's going to be when it asks you to look for a strata attribute definition file, for instance. That's the folder it's going to start. And it's not a folder named project. It's whatever your project is at the time. That's where it's going to go. Okay. But if it is in something like this, it's going to look in project, data, alignments, and profiles. And that's where it's going to start looking for those. Okay. So that's how that part's going to work. But again, for us, for the class, we're just going to keep everything stored where the drawings are going to go. It'll make it easier. We don't have to keep navigating a way to find stuff. Okay, doke. Different settings and database stuff. Current project file. If we had the project, we're not using project folders. So, and these are just some different, like this data depot. You can use project-wise if you're a project-wise organization, or another commercial product called subversion, which doesn't mean overthrow the government. It means it tracks subversioning of different projects. So it's just a different way to do it. All right, so that's what that means. I'll go ahead and leave it set to drawing folder and keep that is the default condition, and I would just leave it set to that. All right, now the drawing setup. This is the default for when you remember when we first started, we chose English and we chose that scale that came in at 30 scale. This is a vertical scale. That's how much of a vertical exaggeration. That would be a 6-time vertical exaggeration. There's our symbol size, again, 1/10 of an inch plotted at that scale. So it's going to compute 3 feet. This one, 2.4 feet. A line type scalar of 1. And I'll show you that. Keep that in your hip pocket, this line type scalar. We're going to want it set to 1, but when you change these in the drawing setup, it changes this, and we have to keep going back and setting it back. There's a historical reason for that. We don't need to use that anymore, but that's and I'll show you where to come to set that when we get to that. Now, the vertical angle mode, if you're doing coordinate geometry computations, that lets you put in vertical angles if you are doing so, like if you're entering commands based on readings that you took off a surveying instrument, that lets you put those in so it calculates horizontal distances. Here's our coordinate system. Either if you're always in local coordinates or if you're using a grid system, you can set, here's my state plane 83, PA South, again, where I'm set it up. Now the English units, kind of important here, and a lot of people just gloss over this and don't pay attention. Are you familiar with this difference?
Yeah.
Okay, so most of us, at least for now, we're still using the US survey foot. Most of our surveying instruments are based on that, and our deeds and things like that were measured in that distance unit. An international foot, and I think coming in 2025, the US is going to officially switch to that. As
International?
Yeah.
Yeah, right now I only work with customers in South Carolina that typically it's all in international.
Yeah. So what that means is when we're dealing with English units, it's mostly with conversions, but it also has to do with, and you don't see a real difference unless you're getting on really long linear projects like long highway or maybe pipeline work. The US survey foot is based on the relationship of there being exactly 39.37 inches per meter. Okay. The international foot is based on the relationship of there being exactly 2.54 centimeters per inch. And when you do the math and figure all that out, it comes up to a difference in something like the 6th decimal place out as far as where you start getting differences in those conversions. So, and a lot of people you'll see, and a lot of times, and you can't really set AutoCAD to use anything other than just decimal units. So it's whatever you are working in. But we want to always make sure we're in US feet instead of international feet, at least for now. And I don't know what's going to happen once the country officially goes to that. I suspect it's going to be something like the fiasco of when the country was supposedly going to go metric. But we'll see. So anyway, just for us, we're going to leave that set to that. Now, up here on this point prompt and label settings, this is dealing with Carlson coordinate points. And there are, and again, you can do all your work without doing any Carlson points whatsoever. But if we do, we're going to have this attribute layout ID. And you can see there's 0 through 9. There's 10 different ones. And you can see here's one called ID 0, which means it's going to put the point number and elevation and description and the point's going to be right there in the middle. So the point number is centered over the top, elevation is off to the right, and the description is centered on the bottom of the point, and it's using italicized text. Number one is straight text, same thing. Point number centered over the point at the top, elevation to the right, description underneath it, but they're centered. It's not really showing you very well here. The one I like to use is this one where they're all lined up on the right hand. The point would be right off here to the left of this elevation tag. And then there's one like 3, and you notice it kicks up the elevation at a 45-degree angle. And that's useful a lot of times. If you can imagine, we use a symbol, maybe a little X or a plus mark, and then we would freeze off the point numbers and the descriptions, and we're left with like spot elevations drawn off at a 45-degree angle. So you'll see that a lot sometimes. And again, you can switch these at will, but that just lets you choose a particular one that you want to use by default. Now, these other checks are whether or not you want to use descriptions and elevations. Excuse me. If you don't have those checked, then they won't prompt you for those and you won't see those show up. And locate on the real Z axis, that means it's going to put the point at the elevation that the point holds in 3D space. If you don't, it puts them down at 0, even though the point still knows it has an elevation and things are going to compute to that elevation, but they're all going to be down at the 0 plane. I like to see them where they are myself, so that's why they're there. And I will label those that have 0 elevations. You can turn that on and off. And again, you can set these in different places and different commands as well. I'll set my angle format to bearings, and I will use point numbers. I'm going to automatically number my points. So if I'm going to create a bunch of points, I might start with point number 101. And, and then when it says automatic point numbering, I can control that to say, or add 1 to the point number and just keep going from there. As you need to assign a point number, go to the next available. Now, point numbers can also have letters in them. That's what the Carlson alphanumeric point numbering means. So if you have like a CTRL1, the next point would be CTRL2, CTRL3. But if you got a point called, CTRL, the next one would be CTRM, CTRN. So it will increment those as you go if you turn the automatic point numbering on. We generally use numbers only, but you don't have to limit those to numbers. You can use letters as well. And then we're going to use our drawing setup source on startup. Either use a drawing template or use the configuration. Use the configuration. It's going to take some of these other things into account and apply them to the whatever template you use. And that's really about all we need to set here. Again, whatever you mostly start with, you can set that as the value here for your horizontal scale and set up these sizes. Okay, so we'll set that as an okay. Now, the biggie here is this general settings. And this is where if you've ever checked that box to skip the startup wizard next time, it turns it off and you can't get back to it, except if you come back in here and you do want to come back, that's where you turn it back on. So I would set these as you see here. A couple ones I'll point out is this save the drawing INI files. Now what those are when we've worked with a drawing, you see these drawing names, and you're going to see down below here some of these .ini files. Here's one called Grading Design INI 01, Grading Design 2 INI, Grading Design Complete INI. So if I look at that file, if I edit that file, it's just a text file. Well, there's nothing in it. Go back to it a minute here. Let's see. Let's open with Notepad. There it is. So this is a file, and it usually builds it from the bottom up. It started with this, and every time I've used a particular file with that drawing file, it has assigned these files. Here's one called Main Street Centerline. Grading Design CRD, here's a Main Street Centerline. So all these different things were used in building that file. Now, this is helpful if you ever send this file off to somebody else and they're working with it and they say, well, you know, I didn't get your surface files. What did you use? Well, you can go back and look at this and see, oh, there's a file. I need to send you that file also, or I need to send you this section file. I need to send you this, you know, your road design information. Here's another existing ground file, phase 6 original ground.10. You know, and you'll see up here, it's pointed to it again as a different earthwork section file, you know, that started with that one. So it's just a way of listing different files that got used with that. So it's useful to save those so that you can go back and refer to them. They don't take up a whole lot of room, but it sort of keeps the history now. You know, you may never look at it, but it's good to have them there. Now, this ignores zero elevations. If you don't have that checked, when you go to build a surface out of your data and you select a bunch of data, let's say by a window or a crossing or something.
Yeah.
If those things are drawn at zero elevation, with that turned on, then they're selected, but they're ignored. But you don't want to build something that, you know, it's up at elevation 1350 and then suddenly it drops down and picks up things down at zero, because you're going to get these really weird surfaces, you know, that drop down to nothing.
Yeah.
So that's a nice one to have on. Where it gets to be a problem is if you're working, say, down at sea level, where you could potentially have something that has a true elevation of zero, and that needs to be incorporated into your work, then you would make sure you uncheck that. Now, that also shows up when you go to compute different things in the process of building surfaces and such. You'll see that as a checkbox as well, and it's pre-checked because we've got it checked here. Okay. So these others I'm going to just leave for you to set here. Now, one thing I will point out on your system, this use software rendering, I would leave that unchecked because you want to use hardware rendering on yours so that your graphics card can take care of some of that rendering. I'm running this through Parallels, which is a Windows emulator, and that's why I have to use my software rendering. I don't have access to the actual graphics hardware on my system. So leave that one unchecked on yours. Everything else I would leave on. Here's that enable file selection graphic preview. That's that little opening dialog box. I told you sometimes you'll see a little preview. That's what does that. I'm setting the menu bar on startup, which means I'm going to start with my pull down menus. Otherwise they would be off. My AutoCAD menu that I want to use is whatever particular AutoCAD I've got chosen and I want to switch to. And that's if I switch to this icon up here, you see in the toolbar that red A, or that lets you switch to a different set of menus. This use annotative scaling, and here's my prefix. I'm using equal or inch mark equals, and then foot mark is my suffix. That has to do, are you familiar with annotative scaling?
No, not really.
Okay, so, and that's more for like plat finishing and finished drawing kind of stuff, which you're not going to be dealing with a whole lot. But if you do that, that lets you create text. And if your text style is set to be annotative, then when you change scales, it's going to change the size of those text elements that were annotative to react after the fact. After they're created, you change scales, it will change those sizes for you. It won't hurt to leave it on with yours, even if you're not using it very much. But it's just a way of resizing those so you don't have to go back and relabel things. Okay. When you change scale. Otherwise, the scale stays static as to whatever size it was when it was created, and you have to go back and change the size on them. These other coordinate reporting order, the date format, the document format, you can have it create a DWF or a PDF when you go to print your drawings. Report viewer. When it comes up, when you do things like list coordinates or list a centerline report, any of those things, here's the default ways you can go into the Carlson viewer, Windows Notepad, or Microsoft Word if you have it installed. I like this Carlson report viewer because it has some tools in it, like you can dump the report into the drawing and it creates drawing text for you. So that's a nice little handy feature with that. You can do things like save files and append other files, all those kind of things from within that report viewer. It's just a little text file viewer. And you'll see when we get into some of the reports. For the digitizer, unless you are using an actual digitizing tablet, go ahead and check use mouse so it doesn't try to turn a digitizing tablet on and off. So this part doesn't matter down here as long as you're using the mouse. Okay. Now, the others over here, the coordinate file format. Again, you can use numbers only, but the more default, the more flexible default is to use alphanumeric point numbering. So we have letters and our point numbers. This other one, Carlson SQL Lite, is the, and it's basically the same CRD file, but if it's a B, an extra letter in the extension. And what that does is if you're using a lot of points that have GIS data attached to it, that will store that data right in the coordinate file with it. Otherwise, if you're using this, you can still use that data, but it links it up to another file with a .gis extension on it, and it just matches up point number to point number. So it keeps them as separate files. Otherwise, if you're doing a lot of that kind of stuff, probably best to use that particular one. And then C and G, numeric and alphanumeric, that's the old Cowherd and Goodman survey system. It's more of a legacy thing. So again, by default, Carlson alphanumeric is going to give us the most flexibility. Now, these object linking. Notice I have everything checked on here. And what that's going to do is link points with coordinate file. So if I have that on, if I put a point in here in my drawing, it came from a coordinate file, or it's writing to a coordinate file as I create points in the drawing. If I then move that point in the drawing, it's going to update that coordinate file for me. Okay, so and again, there are tools, whether this is on or off. If I go to move that, it's going to pop up a little dialog that says, hey, you're in a different position. Do you want to update the CRD file? Yes or no? So that's probably something to always have on, just as a safeguard. Linking line work with points. So if I've got a bunch of points and I said, draw a line and go from points 3 through 8, and then if I move those points, the line's going to pick up and go right along with it. Okay, so that will change the shape of that line. Now, if I grip edit that polyline maybe that I drew through points 3 through 8, if I select the polyline later and just drag a grip out, it does not move the point to where the grip went to. And then if I were to regenerate the drawing, it will put that back right where it came from with this point. So it keeps those linked into that point location. And linking labels with line work. Labels are things like annotation. If I go to, hey, I've created, say, this boundary around my property by drawing from point 1, 2, 3, 4, 5, 6, and back to 1. And then I've labeled them. I get the bearing and distance along those lines. If that line work then were to change, even if I grip edit that polyline and move it somewhere else, it's going to recompute and redisplay, erase the old labels, and redraw the new labels all automatically for us. Same thing it does with center lines. And if I've created a center line, I've drawn it out in the drawing, and if I move any part of that graphic, it's going to update the .cl centerline file automatically. If I go into the centerline file and make edits numerically in that file, and if I save it, it's going to redraw that alignment back in the drawing. And we'll see a couple of examples here in a minute. And then grouping the point entities means it's going to group the point number, elevation, and description, and the point symbol all as a single group. So if I move any one part of it, it's going to take everything with it. And then maintain the coordinate history file. So if I make edits to the coordinates, I can roll those back with that history on. So it's also a handy little feature. And then this part down here, removing arcs. And this has to do with something. I'll show you an example that we'll go through a couple of things here in a minute. This maximum offset method or chord length method, what that means is here, and just go ahead and set these numbers and I'll explain what these mean for you I'll show you with an example. The 0.02 as a maximum offset and a chord length of 0.5, but I'm going to choose this maximum offset as a method that I want to do. Now, removing arcs, you might say, well, why would I want to remove an arc? Well, that's not something that you go and do manually. What that does is when you have a true arc, which is only available if it is a flat planar arc, so it's truly circular. But if that is in plan view, it looks like an arc. Let's say it's a curb return going up into a parking lot. In reality, that's going to mean to maybe start at the PC at some elevation, and it's going to wind its way around the curve and wind up at the PC at a different elevation. Well, that's not truly an arc. At that point, that means you've reached down and grabbed one of those points and pulled it up higher than the other point. And so now it needs to go from the starting elevation around the curve, the arc, up to the finishing elevation. And it can't do that in 3D because now it's no longer an arc. It's been stretched, because now if you're looking at it normal to the plane that it lies in, it's no longer circular. So it has to remove that arc and replace it with a bunch of line segments to get up to that other point. And it's how do you build the line segments? And if we say the maximum offset, that means it's going to place those line segments so that the maximum difference between the plan view location of the circular element and the little piece of the arc of the line segment, that maximum distance is going to be 0.02 of a foot away. So I'm going to say, hey, you know, that's going to be close enough for building purposes, and that's what I'm going to use. Otherwise, it's this arc length. So go ahead and set those numbers and I'll show you some examples.
Does that, so that would be, it would basically calculate how many basically line segments are inside of that arc, correct?
That is correct.
Like how many it basically will determine how many vertices you get in your arc at that point.
That is correct. That is correct. Okay. So here's an example. Go ahead and let's put this maximum offset. Let's go ahead and set that up to 1 foot. Okay. And let's set our chord length to 2 feet. Let's just set those right now. We'll set this max offset. We'll say okay. And then we'll say exit. And it's going to say, hey, you made some drawing setup changes. Do you want this to apply to this only future drawings or this current and future drawings? So we'll just go ahead and set that. All right. So we've done that. Now, let's talk about this arc for a minute. Let's do a ZC, which stands for zoom center. And let's go to 5,000, 5,000. So that's where we've set up. And we're going to set our magnification or height. Now, this means the height from the bottom of the screen to the top of the screen. Let's just set that at, say, 500 feet. Okay, so now I've set up, and if you look down here at the bottom, you see these coordinates on the bottom of your screen.
Yeah.
If you look, I'm at like 4980. If I, for my X, let's see, what's my Y is 49, 48, about 4,800. And that for the Y value. And if I go up here, it should be about 5,300. And there it is, 5,239. So that sets my view to be 500 feet. And I'm centered around 5,000, 5,000. That's just basically so we get a sense of how big we are. So we're going to draw a polyline. Let's go to the draw menu and let's choose a 2D polyline. And let's, if you don't see this box, type the letter O and it should bring the options up.
I got it.
Okay, so we're going to leave it at elevation 0. And we're going to so come down here, make sure we don't have this autocorrect turned on. And let's just use the current drawing properties. So whatever layer you're on and whatever color and all that, it's going to use those. We'll say okay. Now, it's going to prompt us to pick a point or point numbers. If we're using Carlson points, we could use a number, but we're just going to draw a point here. And we're going to, let's, and you can just click your way around it. I can see that's, you know, a couple hundred feet maybe. I'll say here. And, you know, you could then type the letter A for an arc or whatever. But let's just go ahead and draw something like that. Just a little two segment. I don't, it doesn't have to be, you know, rectangular, you know, draw it like that if you want. Okay. So I've just drawn a polyline. Now I'm gonna put a curve in between here. And if I select this and I look over here in my properties, I see it still has this elevation 0. That's what I'm wanting. Now I'm going to put a curve in between here. Now, you know the CAD command to do that with is a fillet. You know that?
No.
Okay. So that's on our modified toolbar, which I've got over here on the side, and you'll see a picture that shows here's a chamfer and here's a fillet that rounds and fillets the edges of an object. So that's going to fit a curve in there. You can do it that way. You can also do, I think, chamfer. I don't want chamfer. I want to fillet. Oh, here it is, right here on the, it's called a fillet. So I'm going to type fillet. Now it wants me to select the first object. And so basically you're going to pick a leg and pick another leg, and it's going to fit a curve in there for us. But I'm going to come down here where it says radius, and it wants me to tell it a radius value, either a number, or I'm just going to pick 2 points. I'm going to say, I want this radius to be, say, from here to here. So that's going to be, that's set the size of that radius for us. I'm now going to pick this leg and pick that leg, and it's going to build that curve, and it's going to trim everything back and keep it all as a center line. Now, there is my curve, and it's all in 2D. And if I look at what that curve represents, if I want to see, you know, what's the radius of that, I've got several ways I can come down here and I can dimension a radial radius. And if I point to this, you know, I see that that has a radius of 56.82 feet. Okay. Now, when I need to convert that, that's a center. That's where the center is right there.
Yeah.
Of that arc. Okay, so that's a true circular arc. Now, if I'm going to make that into a 3-dimensional line, let's say I'm going to start at one elevation, go to another elevation. Let's go to our 3D data menu, and let's say 2D to 3D polyline by start and end elevation. So it wants me to select the polyline to assign the elevation. I'm going to select this polyline, and it wants to know the elevation there. Let's just call it 100. And then it's going to jump to the end. You saw that arrow, and I moved. And so now the ending elevation, I'm going to make that 105. Okay, and now you saw what happened is that now is no longer a what used to say LW polyline. It is now, if I move this, I'd like to get that out of the way there a little bit. It's now a 3D polyline. And so those are those individual segments. Now, let me do something here first. I'm going to, let's see if I do I don't think this will, no. I'm going to undo this back to where it is a true arc. Yeah, let's do it. I want to leave the arc in there. In fact, I'm going to change its, I'm going to select it and change its color to red. And I'm going to now I want to copy that. So I want to save this and let you see the difference. So if I go to edit, copy, and let's just say, well, let's make a standard copy. If I select this element, it wants to know, specify the base point. So I'm going to say start at this endpoint. Now, do you have your object snaps on?
Yeah.
Okay, so I'm going to go from the endpoint, and it wants to know where I want to go to. I'm going to go right back to that same endpoint. So it's just right over top of the original. So there's the endpoint. So now I've got two items there, and I can see that if I cross it, I see up here I've got two polylines. I also see that little indicator that tells me I've got more than one. If I click, it tells me to pick one.
Yep.
I'm going to pick one and set its color back to by layer. So there's the yellow one is on top. The red one is underneath it. The red one is the copy I made. All right. So now if I go back to 3D data, 2D to 3D by start and end, I'm going to pick that yellow. I'm going to start at 100. And I'm going to 105. Now, that's what I wanted to show you. So this distance if I go from the midpoint of that to the perpendicular of the uh, do this, let me draw 2D polyline.
So it lets that distance be one, as no more than 1 foot, correct?
Correct. So now if I look at that, then that distance should be no more than one. Now it's less than one because maybe down here it is.
Yeah.
Yeah, so if I go from say there to there, let's see that. Well, that one's slightly over one. Anyway, that target distance is what that's trying to do. It had to, I guess, because it went to an even number of these segments, then that set that value there as one. If I were to go back to my settings, Carlson configure general settings, and instead of using the maximum offset, let's do the chord length method. And now I'm going to make this a different color. Copy this again. Now, if I do a 2D to 3D by start and end elevation, I'll pick this one. I'll do the same elevations. Geez, yeah, 3D, 2D by start and end. Pick point. Oh, okay, let me get that 3D. Delete that one. Yeah, do I have two? No, let's copy that. Now let's see, did I? Make that say 5 feet. Let's make it 10 feet. I think it did it 2 feet, but 2 feet was too small to see. Let's make it 10 feet. And now if I do that same 2D to 3D, I'll start and then 100 to 105. Actually, it did it. So what is our distance between, if I measure my standard distance from that point to that point, see, that's 9.9882. So it made a 10 foot length. Okay. Now, the reason I use the chord offset method is this. Let's go back. Let's change a couple of these. If I've got one that is set one like this, and I'll set one really sharp like this, and then let me up. Sorry. Let me move those over here and show you the difference what I'm talking about the reason I did it. So if I do another fillet, I'll just keep the same. Let's just make it a 50-foot radius. We'll keep this one to this one. So that's a smallish arc. If I do the same thing, I think I've got enough room. Yeah. All right. So here's why I do the differences in those methodologies. So if I set this up and I'm going to set my 10, let's make that 25, a little higher so we can see it. So if I do a 2D to 3D, again, 100 to 105, I get basically just one segment.
Yeah.
If I do it here, I get that many. So it represents that, every point along those segments is on the original arc. So there's one to there, and so you don't see much here. That's with the segments. Okay, so I'm going to undo both of those back, and if I change that to the method of maximum offset, let's even bump this up to say two foods. And if I do that same thing, starting in elevation, 100, 105. And I do this one from 100, 105. All right, so now I get, well, still didn't really show it. I was trying to say, anyway, what I'm getting at is that the segments that it replaces it with are meant to approximate that curve. And so if I get a really long or really sharp curve this distance, and maybe if I did that, maybe there's a better way to illustrate that. I want to get rid of this guy here. And let's just scale that guy up. So there, make it top time. So if I do a distance, let me copy these again. The original. And so now if I do my 2D to 3D, I'm starting in elevation, 100 to 105. And then I choose this one and go to, there's a 105, 100. All right, so now what I'm left with are replacements. When I'm doing the maximum offset, you see how that applies to that versus, let me take these two things, copy them. And now if I change this back to chord length, and if I choose 2D to 3D, by start and end, this one, all right, so if I were to use line segment, see that line segment from here to here is essentially the same as this line segment here to here. You see those relative distances between those points. It looks to be about the same.
Mm-hmm.
So depending on this, on the length and the you know how sharp the curve is, the line segment part could, you see down here, it starts to, this one is far less representative of the original red line than the green line is. The green was done by that maximum offset. So that no matter the shape of the curve, that's going to give us a more precise representation or approximation of that curve. Whereas the line segment is going to be dependent on the shape of that curve. Okay, so just a couple little things that, I've run into by experience that tells me, that I have, uh, that this maximum offset is going to tell me that, and I'm going to set this now back to 0.02, and I'll set this back to half a foot in case I ever wanted to use that. But I'll use this as my maximum offset. That means no matter the shape of that curve, the resulting bunch of segments is always going to be within 200ths of where that original curve was. Okay. Now, I think by default that used to be set to something really ridiculously small, like 0.0001.
Yeah, I think
Now, what happens when it's too tiny? In fact, let's go up here now and we'll get rid of these approximations. Let's get that, and we'll copy those now. And to there. And we'll go back now to one last time. Starting in the elevation. So now here's the trade-off that we're going to get into. When you make that too tiny, and right now it's set to 0.02, so it's pretty representative, but look at all these points that it creates. Now, what it means is this: if I were to go to start to build a triangulated surface in here, every vertex along this line will form a triangle. That will be a point of one of our triangles that we build. Make that number in here so small that you get, point, you're going to wind up with thousands of little triangles in here that may be too much. You're making your surface unnecessarily complex. Sometimes even overwhelms the controller on your equipment, so you have to thin that out. And there's some other tools you can do that with. But in general, and these are pretty big size curves. I mean, these are these are not parking lot curves. If they were like a 5-foot radius, you would see it a little more representative. And so the trade-off there is to make sure that you don't get so many that you're winding up with too complex a curve, but you also don't want it to where you've got something like I'll just draw another. You don't want it to be something like this. And I've seen modeling done like this to where that's the actual surface model, but you got a lot of distance in here that
that makes it inaccurate around the curve, though.
Exactly. So if you go out there and you grade to this specification, which your machine will do, it's pretty dumb. It's going to read what you give it, and if you're not aware of what's been happening there, you've got too few here, so it makes for only a few triangles, but you screwed up the grading. You need to have that grading closer up in here. So there's your trade-off. And so those numbers are, that we set that 0.02, that's a pretty good representation I've found.
I think now, does that tie into like if you were going to reduce vertices or because that's so this is a huge I don't know, issue, complaint, however you want to call it, of mine with Carlson is, and how I've been instructed to use it to this point, is getting that representation right.
Yeah,
Getting enough triangles to get the data in there, but also at the same point getting the least amount of data to better suit the machines, right?
exactly
But
right.
yeah, but that's where for me it's like, okay, do I reduce vertices, or what's kind of why we're on this subject? I don't know, might be good to dive into that. If you have your line and your arcs, do I convert it to a polyline and then reduce vertices? What would your take on that be?
Exactly. And and there's some tools that have come about that are going to help us out there. So we've got a couple things here. We've got, if I look at this, I've got, these are all pretty close together.
Mhm.
But if you look here, they're way far apart. So there can only be a single triangle formed right in here, right?
Yeah,
And that may be okay. That might be representative, but it's probably not. I've got other data that I'm going to be dealing with. I
yeah.
want that to be a little more
Populated, yeah.
smooth, populated in there, so it's a little smoother transition between them. So that's the one object you can go down to. You can densify those polyline vertices, and let's say I want to densify this one, and I want to make that every 10 feet. All right, so now when I do it, it's put every 10 feet, it's put a thing in there. Now, these were closer than 10 feet.
Yeah,
So that one didn't affect it. If I were to do the opposite there and reduce, now I'm going to give it a cutoff. So this is going to look at the linearity. So as I go around this curve, I'm going to make it something like 2 feet. So if I do that and say there, and now I look at that, see, I've reduced that one down. Okay. And so um, the original polyline or the original arc, you see, I'm now further away from that original arc. You can imagine the circle going through each of these points. I erased those out of there just to get them out
yeah,
of the way. So I've reduced that down. Now that may be okay, but I just sort of have to play around with that and do that reduction. Now, the so you can do that. You can reduce those as you go through it, or you can. I find that I usually have to densify more so than reduce. But on when I go to build a surface, I go to triangulate and contour, I've got a checkbox in here that says to densify my break lines. Now, when I do that here, and I do it as part of building the surface, it's going to, in memory, put in those extra little points,
yeah.
build the triangles accordingly, and then it's going to throw them away. It doesn't actually add them into the polyline. You can do
Yeah,
that, but otherwise this will keep the original as it is, but it will automatically densify that. Now,
yeah,
the opposite direction, if I want to reduce those, is I have to do this simplify surface, which will take the dense existing ground source data, and I can do it by an elevation tolerance, or if I just say simplified surface, I can give it that tolerance there that it's going to reduce those values in here. Especially the maximum distance of vertex can be moved from any of its initial planes. So um, that sort of works on. This is more of an elevation reduction. It doesn't actually get rid of these. It goes ahead and computes them, and then it gets rid of the triangles it doesn't need if it's within
yeah.
tolerance value.
So that's my as we're going to go into the surface building, that's my main issue, right? So that's like, as opposed to doing it, because what I'm coming across is doing it in the line work like this, right? Then you have then now you've, in my opinion, you've corrupted the line work, and now none of the line work lines up, right? You
Yeah.
have intersecting line work, and now you're trying to fix all the little,
Yeah.
odds and ends, right? Sidewalk tie-ins, whatever, right?
Exactly right. And when you can do that, and again, there's your trade-off. So if you start to pull these away and you start to bring this out, you might cross over some other lines that don't work. So
Yeah, no, that's just as going ahead. Yeah, that's I'm good at this point. Just that's just so you're aware of where I'm at with it. It's like,
right.
okay, so now I want to dive in. For me, I'm like, okay, in my surface, creating my surface, I want to dive. I've messed around with those settings before, and
Mhm.
I don't, from the book I have and stuff, it doesn't give you, hey, go this direction or go that direction. It just says, oh, do this. And so that's where,
Right.
I might
Yeah.
need your kind of say, hey, lean this way or lean
Mhm.
towards this number, and and
Yeah.
then you can find your happy place. But
Exactly. And that's you, and usually that's what I would do. Like I've come up with that number, that 0.02 as that maximum offset. And it depends if you're doing, 60,000 acres, or if you're doing, a single 7-Eleven on a job site, I wouldn't bother. I would just leave them like that. But if it's something huge, and this is just going to overwhelm my equipment, like I did a job for there's a big engineering firm out in the Richmond area called Timmons, and they were tasked with building the North Anna nuclear power plant, and it was something like I don't know, 400 acres or something like that, and they had all these parking lot curbs and everything in it, and it was just a mess. They had more data than would fit on their controllers, and so to fix that, we could have gone in here and, reduce this down and tried to play with all that line work. But I found it easier at that point to go ahead and generate that really complex surface. And then I would go to this, you know, triangulation. I don't know that. Let me see the utilities. I have to load. I got to load a file and just load up a
no, I
file.
don't, and I don't mean to distract you or derail you here, but
No, no,
yeah, that's as we go down, get to that point,
yeah.
that's where.
Yeah, so what I would do with that is I would come in here and then do the simplification in here, and then that kept everything sort of intact and only got rid of those things that were so close to tolerance that it didn't matter. And then
Yeah,
it's iterative. You've got you've got some different things that you have to play with, but sometimes you will need to go in here and say, well, that's just a little too dense, and that's the tool. Go to edit, polyline, reduce the vertices, and that will permanently reduce them out of these. So that's, again, it's trade-off time. You got to sort of look
but yeah, but for me, like in my experience, right? So I got a lot of time as the grade center, right? So
yeah,
I don't, I don't want reduced, I don't want them reduced like that, because if I'm going to go stake some, say I'm on the field, but I'm going to put a catch basin in, and just so happens it's on a radius or whatever, right? I want to, know, hey, this is face a curb, and you
right,
know, that's where it is.
yeah. And so what you want to do with that, though, is remember how I copied that 2D. uh,
Yeah.
and there's some of these commands, and I thought that one did it, but it doesn't. There's some of these that if you convert by screen entity, see that option, keep existing polylines. You want to turn that on, and you can keep, like I usually do this, and I'll put all my resulting 3Ds, I'll put them up on a break line layer, but I'll keep that original single 2D with a circular arc. So then when I stake that curve, I can get the PC, the PT in the center of the circle, and I can go straight to, if I need to go to the midpoint of the arc. Um, in fact, I think that, yeah, see, so that lets me actually find that, these particular points. There's the
Yeah,
center
yeah,
point. I can go to the midpoint. I could, find those actual points that are in plan view. That's going to be where they are.
yeah.
And I would set the elevation of that point based on the corresponding 3D that was nearest there. That would be, where I would set the point's elevation.
I know.
So yeah, it's all a matter. Yeah, you don't want to reduce it so far that you're too far out from reality to be able to.
Yeah, yeah. I mean, there's obviously a tolerance, but yeah, yeah, you're
So, all right. So we are into our lunch hour break. That's basically all you need to know on the settings business. And
okay.
again, that's where those are sort of the sweet spot numbers that I found work for typical site development kind of stuff. All right.
Gotcha.
So we'll come back from that. Now, a couple of real, uh, I'll show you one of those other linking type uh, things. Let's go ahead and throw a curve in here. And so if I were to say, annotate this, I'll just leave the defaults as to whatever they are once this comes on. Well, there we go, fine, right? All right, so they made the line table. Wow. The Telecat version, that pops up real quick. And I don't know why it's taking its sweet time to bring this dialogue up. But anyway, it does. Let me go back to my general settings and go to lines, and let's turn this off. Turn this from these line tables to never. Okay, so let's create tables. There we go. So now I've got distances and bearings, degree of curve. Apparently, you could put radius and whatever else you want into. So now, but part of that automatic linking labels with line work, if you see that bearing and distance, if I now just grip that, edit, see how it recomputes and redisplays. And if I set this to be, it'll follow that and set the new values.
Was that? That was it. That was just the annotate command.
Yeah, that was this annotate. That was auto annotate. Now you can also annotate individual segments, but if you do auto annotate, it does the entire thing, and it's based on these default values of back up where you can set in general, then what to do with bearings or angles, and distances, and where you're going to place them, how far off,
Yeah.
what layer they're going to go on. Um, this you set up your defaults, and that's going to be how it's going to label those, and that is an annotation. There's another annotation. For instance, if I just draw a rectangle, and if I go to my area and I say area by closed polyline, and I'll put that in here, lot description 1, and I'll place it right there. Okay, now if that should happen to change, see what it's doing. Now, understand what why they give you the choice, because you say, well, why wouldn't you want to always have that on? Well, some people do, but here's why they give you that choice. Let's say I'm a surveyor and this is somebody's property, okay? And I've grown the property maybe that I found from these given points out in the field, but then I need to set the bearings and distances to match a deed. So it's going to be slightly off on those corners. But then if I want those to be the ones that are set, again, I would do this auto annotate, wait for that to come up. All right, my offsets are obviously way out of whack. So I'm gonna do these in a little bit. And again, once you know that, this is the nice thing about Carlson is that these things are nothing in the world more than just plain old text. Now that they maintain their linking to the lines and such like that, but it's still just, if you look in the properties, it's just an in-text value because I had my default set to use in-text. So let's say I had those done, but then if I, and these, I set it to match my deeds. And then if I needed to tweak this or maybe cut a little gap in it to go around a circle, then those things are going to change slightly. So if it's just slightly off, notice those values change. Now it goes back to the original offsets. I need to set my default differently. But so what can happen, and it also changed this set the square footage and acreage. So if I have my linking on, if I go around and I start to tweak these little edges here, these numbers are going to change. And if I'm not aware of that, I could wind up misrepresenting somebody's, property ownership. And so I had a surveying company down in Charlotte years ago when I was doing some of this training down there, that once I explained how that stuff worked, the guy goes, oh my gosh, everybody go back right now to your office, check your machines and see what it's set to. And some had them set to linking was on, some had them set to linking is off. And what happened was, they had multiple people working on the same file at different times. And when somebody's doing something and they're not aware of it, they're doing it with linking on. Somebody else works on the file later and he doesn't know that. And so when he's drawing stuff and linking is, and it's whatever is it set to is how that behaves at the time you create the annotation. And so, some had them on, some had them off. And the guy goes, oh my gosh, that explains the last two lawsuits we had, because they had some things that kept tweaking the numbers and they weren't paying attention because the changes were slight. They weren't very noticeable. And so, they put some things in and they wound up, screwing up some surveys because of it. So that's why they give you that choice. But as far as what we're going to be doing, that's not going to really do much for us. We'll take it from there. All right. So let's take our break here. It's coming up on a quarter till. So let's just we'll start back at a quarter till the next hours. That'd be 1:45 for me, 1:45 for you. And we will pick that back up.
Perfect.
Okay. Any questions you think of, just let me know. I'll pause the recording. Okay. So yeah, we finished up some of the settings stuff, and we're in the middle of sort of getting their feet wet with some of the things going on here. So let's take a look at a couple of things here. If we come back to our surfaces now, like you're already like building terrains and things like that. How familiar are you with the concepts of brake lines and what they do. And
Oh, I'm good there. I mean, the
okay,
whole
so you
yeah,
know when and where, and like for instance, here's one of my favorite little examples, like along these curb structures, you know, how we got to have that brake line down that face and across the top to prevent things like, you know, these invalid triangles jumping across, say, from A to E. You know, we need that brake line in between there to keep that from happening.
yeah. My only hang up or issue with that is when we have break lines or feature lines, whatever that where you still get that happening, and whether you tag the hard break as a hard break line or you know seems like I still have some issues with every once in a while there'll be a spot that pops up that just doesn't like to cooperate.
right. Okay. So now the one good thing about Carlson is Carlson doesn't even, you know, Carlson has a thing for your brake lines. For instance, you can, let's see if I can find where it might be here. Even, or there's a place where you can tag. I'm trying to see where it might be. Oh, yeah, hard brake lines.
Yeah, and then
Tag
tag.
hard brake lines. That's, you notice I didn't know where it was right offhand because that's something you don't really even have to do. What that does, and all that really does, is this. I think it'll explain it.
Yeah, that's why because I my coworker was just, we'll just do that, and then I don't seem to it doesn't seem to do anything hard half the time, so I don't know.
Yeah, let me see if I can find it. Tag. Let's just look for hard. Yeah, so really all that does is this. It just polylines that are drawn in there that you want to use as a hard brake line, and you identify them as hard brake lines, and all that does is it keeps the contouring from smoothing. If you turn on smooth contours, the
Yeah, yeah,
contour that it draws won't smooth as they cross those brake lines. Okay.
gotcha. That makes
And
sense.
that's the only effect they have. So here's a couple of things to consider when we are, if we're building a model, and if we contour, if we draw the contours when we build that model, you can say use contour smoothing, no smoothing, or Bezier smoothing, and then you can, you know, change the amount of smoothing.
Mhm.
I'm not a real big proponent of doing that necessarily, because all that's doing, all in the world that does, is once it generates the polylines that represent the contours, it goes through and does a little polyline edit on those lines and smooths them out. It makes them look a little prettier. That's all.
Yeah.
It doesn't change the surface one iota. And
No. Yeah.
there's,
Yeah. I
there's a
understand.
really good uh, really good illustration here if I can find it real quick. Let's see.
Yeah. Essentially, all that is yeah. It's just to make the contours look a little better on the screen.
Right.
So,
And so, but it's a good concept though that I think it's important, since you're talking about doing that as part of your workflow. Let me see if I can find where this might be. It's a series of articles that I wrote for American Surveyor magazine. Let Let's see here. Find it here a minute. Here we go. Let's see if, yeah, it's this one right here. All right, so if you'll forgive the watermarks, here's an example, and I'll just talk you through with the pictures here and talk about what we're talking about. So I've got a parking lot out here that I have to grade, and I've got a building that's set to a particular, I got a little 10-foot sidewalk across the building, and it has a little 2.08% cross slope from this building elevation. So 10 feet away, it dropped it from say 101 down to 10 or to 100.5. And it set that edge of the parking lot. Well, then I want my parking lot to go down 3% to this point and 1% to go down to this point. All right.
Yeah.
So that's our typical design scenario. Now, what happens is if I were to do that and compile that into a surface with contour smoothing turned off, it would design that surface just like you're seeing here, which basically goes from this corner down to this corner, and there's a hard crease right down that triangle. And
Yeah.
there's basically only the two triangles within here. But that's not really what I want. And some people are mistakenly thinking, well, if I smooth my contours, I'm going to get something that looks like this. That's the same surface and the smoothing turned on. Oh,
Yeah.
great, like nice smooth contours. The problem is the surface underneath that, the
It's the same.
surface you put on a thumb drive and stick on your equipment, still has a crease running from here straight down to here, and there's just two triangles. So
Yeah.
the solution to doing that is to add some data in between here. And the first bit of adding there that I basically identified this line and identified this line. Well,
Yeah.
that still wound up, or it kind of gave the general trend of these contours better, but you're still seeing that little jiggy jaggy looking stuff. And that's because the triangles only formed from point here all the way across to this other point, straight line across. And that's why they did this. Now, some people will get a situation like that and they'll go in there and they'll start playing this 10 edit trick called swapping triangle edges. And so they get those to smooth out, and that does okay visually, and it might, you might be able to fix a few things like that, but still the better approach is to take these, if you look at these horizontal green lines, if we had lines that went across from this edge all the way up to this edge, and then we densified those lines as they go across. So we're going to take, and here's a picture of that spun up in 3D where we drop down off the edge of our sidewalk and we set that point, and then we go that 3% down, this one went 1% down, and then we cross-laid these on, and then we densified all of those different points. So then when it generates the contours, all the triangles now form in here, these smaller triangles throughout this whole surface patch. And these are those resulting contours.
Yeah.
With contour smoothing is not even turned on, it's off. You see right here. And so that now will make a true smooth, gradually smoothing surface without having that big crease down the middle. Okay,
Yeah.
so that's what we want. And you see that's different from this with the contour smoothing on, which is just a cosmetic change to this drawn polyline, and it does nothing to modify the surface. Whereas what we need to do is learn how to densify this information in here and to modify that surface. Okay.
Yeah, I
So
agree. I like that. Because with my background, right, I could go take a laser out to the same parking lot, and I would hub it, like, or you densified your, that's the way I look at it. Is like, okay, how am I going to hub this to actually grade it with the blade, right? So
exactly.
I like that. Could you send me this article, or
Oh yeah, sure. Let me,
yeah, be good to have.
And it used to be they had them online. It's been several years since this was published, but I can
Yeah, later.
no, I can do it. I can send it right now from here. Let me get to that.
Yeah, that's a good illustration of that right there.
And this will be to Justin Robbins.
Yeah, thank you.
So, yeah, and that will talk you through those different things to consider as well. Now, a lot of this stuff. Now, what I did to generate this is added cross lines and densified. I actually drew those lines in. I drew a line from corner to corner, and I arrayed it up, and then I set the elevations from the endpoints, and then I densified these lines. I no longer have to do that densification now because that's built into the triangulate contour command.
Yeah. Yeah.
So, in fact,
Yeah, that's I would say, yeah, that's what I would do. And even now, and then in Trimble is just, draw your break line across, and then it gives it that definition, and it
exactly right. In fact, let's do that as a little sample exercise here. We'll sort of recreate this same thing. So I'm going to draw a building here, and I'm going to set it at a particular elevation. So I'm just going to draw a rectangle, and you can do that from draw rectangle. And I'm just going to click a point, and then to give it the other point. Now, do you know how to type in what are called relative coordinates?
No, I haven't done that.
Okay, so when I clicked a point and it wants to know the other corner point, or you can give it the area and dimensions or rotation down here. But there's another thing. I could just type in a X comma Y coordinate value if I knew where that was going to go to, or what's called relative coordinates if I use the at symbol. And this is just pure AutoCAD. This is nothing to do with Carlson. So I want to go at X comma Y. That means from my starting point, go, and let's make, what's their building size going to be? Let's make it say 30. So I'm going to go 30 to the X, and I'm going to make it say 50 feet in the Y direction. So from where I started, 30 feet X, 50 feet Y. And there's now that building. Okay. And in fact, let me I'll go to my layers list here just to make things happy, and I'm going to call that a building. And let's make it blue. Make it a little lighter blue so you can see it on the screen a little better. And we'll put that on our layer building. All right, so there's my building. And let's get that, let's give that a finished floor elevation. Let's say, and I'm just going to select it. I go to my properties. And I'm going to set that at say 105.35 at my building elevation. And I think I can even well, we'll just set that there. That is now, it's still a 2D polyline, but it has a specific elevation. Now, I want to set a line 10 feet away that's going to represent the sidewalk. And I'm going to set that to be at a downslope from that building. Okay, so I can do that a number of ways. Is I can first draw the line. So I'm going to just draw a 2D polyline. So I'll draw 2D polyline. I want to set it. I'm going to uncheck this, use current drawing properties, and I'm going to call this sidewalk as a layer name. Let me put this in all caps so you can see it better. And I'll say, okay, and I'm going to snap to that endpoint, and I'm going to snap to that endpoint. All right, so now it's sitting there and it's right over top of that other one. And I'm going to change my sidewalk color from white. I'll make it say this sort of pinkish looking thing. All right, so it's sitting there on top. Now, I want to move that over 10 feet away, but I want to drop it down to a 2% downgrade from, so it's got a little 2% fall across the sidewalk.
Yeah.
And I'm going to do that. There's a couple of ways you can do that. You can do the calculation, and then you can move this 10 units this way, and then change its elevation to whatever that calculation was. That's the sort of manual way of doing it. But I can do, and if I do an offset, if I do a standard offset, it's going to take that, and you see if I select that, it still has a 0 elevation, but I want to set that elevation up to match my building. I can either do that, copy this and paste it, or I'm going to go to 3D data and change elevations. And I'm going to set them to an absolute elevation.
Yep.
And we'll say, okay. And now it says either select or enter an elevation. So if I knew an elevation, I could type it, but I'm going to choose my option S to say select. And so now it says select line work or text of elevation. So that's the elevation I want to use, is that one right there. It says now select the object to change. So I'm going to select that pink line. And then I'll hit enter to finish. And when I select that, now you see it's got that same elevation. Okay.
Yeah.
Now, to make that 10 feet away, but down at a particular slope, I need to use a 3D offset. If you tried to do an offset, and a 3D offset will work even if it is not planar. But so what we're going to do is offset that with a 3D offset, and that's going to be let's see where my no, these are my standard horizontal offsets, but if it's
I don't know where that. I always just type in offset 3D and then it'll pop up.
Yeah, it's this one right here, offset 3D polyline. It's under the 3D polyline utilities command. And you see that icon right there? It looks like the AutoCAD offset command icon, but it's got a Z next to it. Now that's also available up here, and this is where I always do mine from, is right here on this offset 3D polyline. That's on the polylines toolbar. So that's a nice handy toolbar.
Yeah.
So I offset that by 3D, and I'm going to do this time by interval is going to be my preferred method here. I can go to a constant elevation or target a surface, that and the other. But I'm going to say by interval, I'll say okay. And I want to say my horizontal offset amount is 10. And my vertical amount, and I can either give it a number or I can type P for percent. I'm going to say -2. So I'm going to give it a 2% cross slope. I'll select that guy and I'll go to that side. All right, so now I no longer need this one. I'll select it and delete it. So now I've got this one that is now at 101.15 instead of 3.5 like the original was. Okay. Now, if we make a parking lot, we're going to have, and let's call it, say, 9 by 18 foot spaces. So we'll have an 18-foot bay of car parks, 24-foot drive wire, and then another 18 feet. So 36 and 24 is 60 feet away. So I'm going to offset that one 60 feet. And I can just do a standard offset on that of 60 feet. I'll take it here and go that direction. Now I've got it where I want it to be, but this is not at the right elevation. So we're going to set the side slope so that it goes, what did we say, what was our article? 3%
3%.
yeah. So I'm going to go to my draw 3D polyline.
Yeah.
And this time I'm going to also put this on sidewalk. Actually, I should probably call that parking lot, PK lot. And we'll set it to be by layer. And we're going to say prompt for elevation and slope. So I'm going to start here. And it reads that elevation. That's down here on my command line. If that's, I'll hit enter. And now where do I want to go? Well, I want to go to here, but it's asking for that same elevation. Well, that elevation I don't want. I'm going to type P for percent. I'm going to say -3%. And so now that has been set at that elevation. Now let's come here and just park lots. I'll make that green. All right, so that now has an elevation up here at this end of 10.15, at this end 99.35. All right, so that was my 3% line. I'm going to do that same thing. I'm going to draw a 3D polyline. Keep everything the same. I'm going to go from here, accept that elevation, and I'm going to go to here. And instead of accepting that elevation, I'll type P for percent, and I'm going to go only -1%. And now that's set. And now this is, I mean, if I were to look at this stuff right now in 3 dimensions, just to show you how it's setting up, there's a couple of things I can just spin that up. You can see how that's actually, see how that edge is dropped down 3%, and this one was dropped down 1%. So that pink line is sitting up at the same elevation as the top edge, but it's not corresponding.
How did you rotate that in the 3D?
Let me get rid of these points down here. What I did to rotate that is I held the shift key down and I pressed and held the wheel on the mouse, and I keeping everything down, and I press and hold the wheel and then move it around while you're keeping it pressed. Okay, so that lets you do that.
Yeah.
So there's other ways of doing that. And one of the things, like I'll sometimes do that for a real quick check, but a lot of times what we're going to get into is we want to use this 3D viewer. So we have the 3D viewer. It's a drawing viewer, and we select the things in our drawing, and that's going to pop up this window that we can resize, and then we can, spin that around and look around. There's all kinds of tools. We're going to make a lot of use of this later on as we start to,
Yeah, but just for a quick check, I like that.
for that quick check. That's exactly the way to do it. So now I don't even really need this, or because they meet at the endpoint in plan, I can say 2D to 3D by screen entities. And I'm going to ignore 0. I can give it a tolerance if they don't meet exactly. Extrapolate the ends, keep the existing. I'm not going to, but I will set the layer name for the converted. I'm going to put that on parking lot. So now reading my prompt, select the lines to convert. I'm going to convert that. And then select surface 3D faces lines and polylines. So the ones I wanted to get elevation from are those two. I'll hit enter. And now when I look at that in my 3D viewer, I see that it actually connects right up. Okay.
Yeah.
So that was one thing I could do. Now I could also do this same type thing. I don't even really need that part anymore. It's there. It can be used at the edge of my sidewalk. I can leave it there. But that's actually the top of my sidewalk. But what is my sidewalk is typically going to be 6 inches high, right?
Yeah, typical.
So I'm going to set and that's the top of curb, if you will. So it needs to drop down to the bottom. Now it's nominally vertical, but we can't have a vertical edge in terrain modeling and surface modeling for triangulation. There's some mathematical reasons for that. So what I need to do is I need to offset that with a 3D offset. And I'll just go back to my 3D offset tool, go by interval. And this time the horizontal offset, I'm going to do just a little bit. So I'm going to take it out 0.5. So I'm just going to kick the bottom out a little bit. And now my vertical offset amount, I'm going to say negative 0.5. So drop it 6 inches. I'll select this. I'll come down here and set it there. And now I've got these two, and they're slightly off horizontally, but they're 6 inches off vertically. So now these edges really need to go to here instead of to here.
Yeah.
So I can do that same thing by just dropping all three of these by 0.5 foot. So quickest way to do that is just go to 3D data, change elevations. We'll say differential. And we come down here, the elevation difference is going to be minus 0.5. Say enter. Ignore zeros, doesn't matter, yes or no. Select the objects. I'm going to select those 3 objects. And now they're done, and select another. No, I'm finished. And again, back to my viewer. And I'm going to see that as I zoom in here, I did indeed accomplish what I meant to accomplish. So I'm 0.5 foot lower down now with that edge of my parking lot, and my sidewalk goes up here to my building. Then you could do, you could connect a line back to here and a line back to here, but what's going to happen is when we triangulate this, it's going to create the boundary around there anyway, and it won't, there's nothing out here for it to connect to. So this point will intercept. I don't necessarily need to do that line as it was. So with that done, let's triangulate this into a little surface. And this is going to be, whatever that's at that elevation. So let's go to the surface menu and triangulate and contour. Now, I'm not going to draw any of these things up here. I'm on my triangulate tab. The big thing I do want to make sure I always do is to write that file. So I'm going to check that on. I'm going to choose select. And I'm just going to call it, let's just call it park lots 1. Now notice up here, it tells me I can save it as a 10 or an FLT. I don't have to put the extension on, but where it's going to go, you see, it's still pointing to that same folder where my drawing file lives. So that's what I want. Call it parking lot. I'll say save. All right, so that's the file it's going to create. Now, do I want to use an inclusion and exclusion boundaries? We'll talk about that a little bit later. I'm going to say no, but I'm going to have it shrink wrap my boundary, and I'm going to say I won't do any perimeter reduction. I'll go ahead and draw that boundary, and I'm going to put it on C-topo boundary. That'll be fine. Erase previous contours. I'll leave that set to off for right now. I'm going to ignore zeros. I will set my maximum triangles sizes. That's fine. I'm not going to identify any break lines right now or any of these other options. I'm going to go to my contour tab. And I normally, when I build surfaces, I don't normally draw the contours as part of this step.
Yeah.
You can always go to the surface menu and draw contours from a 10 file. That's what I usually do. But just to speed that up, we're going to go ahead and set this up, and I'm going to do my contours on, say, C-surf-INT for intermediate. Actually, I need to put that down here. And I will draw the index contours, and I'm going to put that on C-surf-IDX for index. And I'm going to use a contour interval of 1 foot every 5 foot for the indexes. Make sure it's contour interval, no smoothing. And labels, and we'll just go ahead and call it that, and we'll put that on C-surf-IDX to keep it the same. And we'll set the text size scalar to 0.06. We use a standard style of, or text style of standard. I'm going to label the index contours only. I'm not going to break the contours at the label, but I will hide under the labels, align it with the contour, and draw on the z-axis. And this time I'm going to say label intervals. I'm going to say 1 per contour. And I double check my selection tab, make sure I don't have any filtering going on. I'm good to go there. I'm going to say okay. Reading my prompt, selecting objects, but read the line above. It says select the points and break lines to triangulate. So I'm going to select all of this stuff and go. And there now becomes my surface and my contours. And it's not what I'm really expecting. Let me see what I've got here. I've got some.
It's just where your parking lot line ran into your top of curb.
Yeah, but if I There's those 1/2 foot drops, and I've got a 1/2 foot drop here. Why do they call it vertical?
It extended, it might have extended it.
I'm going to erase by layer from the screen. I'll get the contours out. So there's the boundary.
Yeah, it's just picking up the little leg in between your 0.05 there. I think it's just
Yeah,
picking
there's not a leg there, and it's stipulating that as being vertical. This is really just the boundary. If I look at my C topo boundary, I'll make that red. And I'll make it I gave it wrong. It's the wrong one here. That's why I didn't show. All right, so that's just the boundary. I'm going to get rid of that. And if I look at this, it's this, it's that
yeah,
right there.
yeah,
That,
because you
yeah,
offset the
that needs to go back to there.
there you go.
This needs to go back to there. Now, okay, very good.
Very good.
All right, so now if I build that surface again, and this time on my contours, I'm going to change this interval to 0.5. And that becomes 2.5, just so we can see the change. I'll now grab this, and there we go. That's what I was looking for. So I had this, and if I look at this surface now, if I look at everything that was drawn here just as the generated graphics, it's going to, at this point now, and there's an intermediate contour up the face of that. That's exactly what I expect to see. But you notice there's this kink down here and not one down there below necessarily.
Yeah.
So what we've got going on with that is if we draw the triangles in that surface, that's what these triangles are going to look like. So this triangle formed, and these over here, we don't, well, you can see here's one triangle that goes from this corner all the way to this corner and back and back. That's why this tripped right across here. If we if this triangle had formed from this corner to this corner, you'd see a different break on that. So if I am back, I'm going to erase by layer again, and I'll add those in. Now I'm going to draw a 3D polyline. From this corner down to that corner, and that will force the triangulation in a different direction. So now if I go back and triangulate that. There we go. That's what I was looking for. It still shows me a vertical edge. Six five. Oh, I snapped to the wrong thing.
That's a problem I have with when I'm selecting a, you know, an elevation for something like that. It always, it's like half the time it's wrong, and then, or the other half of the time it's like such a random number. I don't know where it pulled it from.
The reason it did that is because it snaps to the actual boundary line. So now I've got it pointed down there. And sometimes you have to spin that up in 3D and see. So now we should be in good shape. Well, this should be, yeah, that's down to 0, 1,
That's weird because it only drops it.
when I went, because I zoomed in here and grabbed that endpoint, so it read that directly. When I went down here and snapped to this one, it snapped to that as 0. But because I was doing a 3D, it didn't set that to 0. It just kept what my starting was. All right. So now I'm going to do this one more time. There we go. That's what I was looking to get. All right. So now if I were to draw the triangles, you would see that that would be the triangle formed,
Yeah.
you know, along there. And so if I were to look at that surface, for instance, I'm going to do the 3D viewer, but this time the surface file viewer. And we'll take a look at my parking lot. And let's go to my settings tab, and I'm going to put my contour interval at 0.5. So, or even if I did say 0.1. So that's what that would look like in 3D. And if I also turn on my triangle edge, you can see that parking lot has, you know, it's with that little crease down the middle.
Yeah.
Okay. Now, the only reason I drew that crease in was to force that in that direction, because otherwise it formed across this way, which was not going to illustrate the point I wanted to illustrate here. The article I sent you has that, it did it accordingly. And so now here I'm looking at, there's my step up to my sidewalk, a 2% slope up to my building. So that's exactly as I expect. Now, if I were to, let me erase these by layer again. If I were to turn on if I did that process, and if I'm going to contour from a 10 file, I'm going to use that. So if I did this one when I built the surface, it's again the same type of controls. But if I turn my contour smoothing on, you see how it does that, and I go, oh, okay, that's nice, smooth contours, that's exactly what I want. But that still doesn't change the fact that that surface is still creased in the middle, just like it always was. And then if I go back and I'm going to add these contour lines into my view, you can see they're there. Now they match right where they cross, but you see how this one comes on around, but you don't see it because it's slightly underneath that surface. And if I go to my view control and set that up to be 5 there, you can really see how it lives underneath that surface for part of it. So if I turn my contour smoothing on, and I expect to be able to go out there on the ground and sit on this point here and read the elevation of that surface. In fact, let's look at that. Do our surface inspector. I'm going to clear all of these and I'll just add that surface. And if I hover right here, right on that contour line, you see it's really at 100.04.
Yeah.
Okay, so it's not exactly right. Now, the closest I get to right in here, for instance, that will read right on it because it's where it crossed it.
Yeah.
But by smoothing those contour lines, even though it makes it look pretty, it did nothing to the surface. The surface itself still has that crease in it. Okay. So, no. Get rid of all of those. So now instead of doing that, and this time I'm going to take that off. I'm going to take this off here too, so we can drawing this at the top of it, but I'm going to undraw it. So now instead of doing that, if I really wanted that to be smooth, instead of it being with those sharp contours with the smoothing off, if I triangulate and contour this, again, we're going to draw the contours. We'll get this and oops, sorry, that's with my contour smoothing on it. Still want the other direction, but still, let's just undo that. Contour, and then put my contour, I'm going to turn smoothing off. So we still have that sharp crease. Now again, this time the corner went from here to here. So now if I do that surface, you're going to see the similar type thing, but from a different corner. So there you see. Contour. Ah, that's why. Sorry. It says previous contours. Now, finally, make sure my labels are set to 0. My contours are no smoothing. Okay, and if I get this, even though the triangles form the other direction, let's take a look at that without me forcing that crease. There you can still see it's got a crease, but this time it's actually an upward crease. But we don't show enough contours on, these are every 1/10 of a foot.
Yeah.
So you can see, but the parking lot's still creased. It's got that crease that way instead of the valley crease in the opposite corner. So if I need to make sure that that doesn't happen, I need to add some additional data in there. And this is what we did. I drew a 2D line. I'm going to put this on call it 3D break line. And I'm going to go from here to here. And that's just a 2D line at 0 elevation. Now I'm going to array that up so that I can set those cross slopes accordingly. So I'm going to take this and I'm going to array and I'm going to make my spacing to be 10. Let's see, 10. There we go. And spacing. Well, let's do a number of rows. Let's see, let's make set it down to 5. Elevation. Oh, for heaven's sake. It's getting more complicated than I wanted. Let's try that again. Just a 2D polyline on 3D break line and go from there to there. And that's it. Now, let's do just a regular offset.
Yeah, just do offset 25 and put right in the middle.
Yeah, so if I do let's do every 10 feet. Select this object. We're gonna go this way. We'll just keep going up. Sake. There we go. All right, so now I've got a series of 2D lines, but I need to set their elevations, and they go exactly to there and exactly to there. So 3D data, 2D to 3D by screen entities. And the layer that they're going to go on is going to be my 3D. Oh, there it is. So they're already on that layer. So I'm going to choose this one and all of these. Now the objects I want it to look at are anything with elevation, so they're there. I can actually get rid of that one and that one because the green ones are still there. So now I've got these. They're every 10 feet. And if I verify this by looking at that in my 3D viewer, I can see that indeed they do match and they are connected where I expect them to be connected. All right. So now if we triangulate and contour this one, and this time we're going to change the file to be parking lot 2. Now that's where we get that ziggy-zaggy, because if we were to take a look at the triangular mesh, we would see they went from each of these lines underneath. In fact, let me just erase these mesh lines here. So those are those original break lines, but they went point to point. So it forced these contours to zigzag back and forth between them. And I can fix that with, swapping triangle edges and fixing all that. But here's the problem with that approach is, again, you're going to still get some convolution. If I look at my surface view, see what it did was exactly what we told it. And so I've got these little folds and creases in there that I don't really intend to have, but it's modeling exactly the way I told it to model.
Yeah.
So what I want to do instead, and let me get rid of these things again. I want to make sure that I densify these. Let's densify those every 5 feet. Now I can do that with polyline, densify polyline. When by so doing, it puts those vertices all along those lines and keeps them in there. So that's going to increase the complexity of my drawing a little bit. But the nice thing about the new commands, triangulate and contour, is I can do that in memory only. So if I do that there, and now let's say on the triangulate tab, let's densify the break lines every 5 feet. And then I'm going to say, okay. I'm going to just grab everything. And now see how much that's what I was after, was that smooth transition. And if I look at that surface, which is that parking lot 2, I can see the blues are the actual triangles that formed. Now there's a couple of still little ziggy things, so I could maybe do some swaps in there if I wanted, or I can, and again, those are 1/10 of a foot contour intervals.
That's pretty minute right there.
Yeah, I mean, that's about as smooth as you can make that. Let's say if I were to, let's say, swap a triangle edge, I could take, you've done that kind of stuff before. But the problem I have with doing that is that you wind up chasing this stuff into a corner, and you're not really necessarily fixing. You fix that one, and now you got this one. So if I switch it, but now I messed that one up. So that's what I don't like about doing those kind of edits. But I'm looking at that and I say, well, that's my intent. I could maybe even add, instead of every 10 feet, maybe drop these in every 5 feet. But now if I look at that, it still only has 2 vertices. This still only has those. But when I saw the actual triangles, let's draw this. So the triangles went to that every 5 feet.
Yeah.
In fact, that would do it if I were to take those instead of 10 feet. In fact, if I do this one last time, let's change my densification instead of 5 feet. Let's match the same spacing I had on those others to 10.
Yeah, that's how I, grading purposes, I never, unless it's a real tight, insane grade break change. I mean,
Yeah.
10 foot on 10 foot is tight for a grader.
Oh yeah. Yeah. And this is a 30 by 50. So,
you would never, I mean, then you got to pave it, and it's like that's so minute.
Yeah, and if you were drawing that for to create a map, at that point, once you had your surface as smooth as you need your surface to be, then you could go back and draw your contours, and then you might want to smooth your contours at this point, except it still didn't. Wow, you see how that resulted in smoothing, because it's trying to do all that as it's crossing those lines. So, again, smoothing on your drawing your contours is not something that I typically will do. I'll look at that, and if I've got real sharp contours, that tells me that my surface is sharp and I might need to fix it, or that might be the intent. You know, I might want to have it go from that corner to that corner with a nice valley for drainage. So if I were to add that back in there and keeping these cross lines, so if I add another 3D polyline, and if I zoom in here and grab, say, that corner, what happens? Right, so now if I go from that corner and I go down to this corner, now what would happen if I were to do that is I'm going to get, you see, I got the corner done, but you see where those white lines cross? I don't know if you can tell that or not.
Yeah, another gap. Yeah.
But those white lines go through the air across this green line, they don't touch it. So to be able to fix that is I would go back to that 2D to 3D polyline by screen entities. And this time, even though these are 3D already, it still will let me reassign them. So I'm going to reassign those elevations to everywhere where they cross. And now, if I were to go up and look at that, I'd see that I've got an actual vertex because it crossed and set those elevations.
Yeah.
All right. And so then finally, I did this one more time. Write the file. And now we're back to having, well, I still got contour smoothing on. But now it intentionally went along that crease, and these lines also follow that crease. So that would be my resulting surface is back to having that creased valley. Let's turn these edges off, you know, so, and sometimes that is what you want. You're going to want to, you know, build in a little drainage path or something. So, you know, all kinds of ways to evaluate what your surface is going to look like. And there's the actual triangles, contours, which you can't really tell without something to sort of, but you can see the drop slope on the sidewalk in the building. Now I'm 5 times vertically exaggerated at that point. So really what it looks like is that. So not much, but it still has that little crease in the middle. All right. So understanding what goes into building this, and that's what I'm talking about, when we clear those contours out and redraw them. But this time I'm going to make sure I turn my smoothing off. And there they're nice and straight. Contours are just exactly along the surface, exactly where they happen to be. And there is one also across the face of the sidewalk there. You can see it right there.
Yeah.
All right. So, you know, that that's modeling exactly what we're telling it to model. And so that's why when you're talking about, you know, whether you set something as a hard break line or not, that's really the only thing that hard break lines do is when you tag something as a hard break line is it turns smoothing off as it crosses, and that's all it does. But since I don't ever really typically smooth my contours at all, I make sure that my data is such that it's going to give me what I expect out of my surfaces. Then that will, uh, help to achieve that same result. And I don't have to worry about whether a break line is a quote hard break line or otherwise. In Carlson speak, if it's a line, if it is a linear feature, it is a break line. That's simple.
It could be.
That's
I get
what,
a lot. I get a lot of times where, just say like on curb and gutter, and just random spot, it'll pull from top back of curb to lip of gutter. And it's not. I mean,
yeah,
it's not all the time, and it's random, and it's like, but it's like, okay. So then I gotta go in, and usually what I do is just draw the brake line in the surface manager and just add a brake line there just to get it to go, because it won't.
yeah. Well, I mean, what really, I mean, those things should work as long as they're not overlapping or crossing. So
Yeah.
we do, let me take this guy back out. And I'm going to do a 3D break line. Let's do this by 5 and 0. Go here to here, here to here. And now let's reset those by screen entities. Well, let's verify all of that in my viewer. Yeah, that'll be what I want. And we'll build this one last time. We'll just keep that same file name. Whoa, what happened there? Let me see. Ah, it retained the previous ones it had, but also just updated the ones it didn't have. So to fix that, I'm going to say 3D to 2D, set them down to 0, select all of these. And now let's do 2D by screen entities. We'll set these and we will allow those. Now let's double check. Put no exaggeration. Yes. Yeah, there we go. All right, so now triangulate and contour. We will write the file. We will densify to 5 feet this time since I changed that. There we go. So that's now more looking like what I was wanting to do. Now here's what we got. So we've got a nice surface here that includes the building and this and a little drop down to there. But let's say we wanted to put a curb island in here. Okay. So I'm going to, at this point, because that surface already exists, I could just freeze these layers, but I'm not. I'm going to actually erase all of these things in here just to get them out of our way. So I do have a surface, but let's say I wanted to build, a parking lot island here. I'm going to just draw a 2D polyline. I will put it on my parking lot surface. And let's say I'm going to make it, say, something like that, just going across here. I'm going to make that say 9 feet across. So I'm going to offset that by, let's say, 9 feet here to here. The parking lot's a little small. Let's make that instead of 9 feet, let's make it 5. So there's that one. And now I'm going to draw another one. So I'm going to go from here, I'm going to go perpendicular to here. And I'm going to offset that by 5 feet here to here. And I'm going to move these two things. The standard move. And the from point is going to be mid between these 2 points to the midpoint of that line. And I'm going to take those 2 lines, and I'm going to trim that line in between it right there. All right, now, if they're 5 feet across, a circle out on the end of this would be a radius of 2.5 feet. So if I do a fillet, and I'll type R for radius and give it 2.5 feet. I believe it will let me do those. Nope. All right, well, no big deal. I'll just draw a circle. 2 point. And I will repeat that command. Oops. All right, and now I'm going to take these and trim these out. Now I'm going to join all these up as a single feature. So I'm going to edit join nearest. This gap distance won't matter here. I'm going to say directly connect the endpoints. Okay, that should work. So if I take all of these guys here, they're now one closed polyline going around the outside of my curb island. Okay. Now, to build this as a curb island that sits on this warped surface, what command would you choose to do that? Or you know how
that's a good question, because I've asked a few of my colleagues, and
yeah.
They don't know, and I do this in Trimble all the time.
Yeah, so this is basically draping on a surface. We're going to
that's like
yeah, so it's just like, remember we did the lines that went across, and we said by screen entities, and we picked the edges. So this is the very same thing, except we're going to use a surface to do it with. So we're going to go to the 3D data menu, 2D to 3D, but this time we're going to go by surface model. Okay, so we're going to use that parking lot 3. We're going to select our object, and we can add vertices at grade break if we want. That's fine. I'm going to keep the existing polylines just in case I wanted to dimension the radius. Okay, I'm not going to put any vertical offset on there, and I'm going to put this on, well, let's call it C curve. That'll be fine. So if I do that, it's now created that as a 3D entity right there. It's on that layer called C curves. All right, and so my 2D, this one is still elevation 0, but this has elevation at that point. Get this off the bottom. That is at 99,3153. That's at 993223, 993269. See, I'm reading that down here at the status line. That's one way you can do that.
Yeah.
But there's another inquiry that you might find useful, is this drawing inspector
Okay.
off. And I've just now turned it on. And if I right click, I can say, show me things like layer name, elevation, polyline data, all kinds of different things. I'm just going to look at elevations. And now if I just hover the mouse, it's going to pop up and you can read that. Now watch how the elevation changes as I go along those features.
Can you leave that on as you're doing other things, or?
You can. The problem I have with it is that it sort of gets in the way because you right, oh man, it's here. So I've got to exit the menu and then I tried it again, maybe bring up the options dialog. So I usually, if I'm using it, I'll turn it back off just because it sort of gets in my way, but you can leave it on while you're running other commands. Now, if I look at this in my, well, let's just do a little spin up here, because if I spin it up, you see that green thing is staying down at 0, which is what I want. And I'm going to use that for labeling if I need it later. And if I rebuild this surface now, and incorporate that yellow line into it, then if I have that switch on that says ignore 0 elevations, even if I select it, it won't be modeled. Now, here's what we're going to do with this in terms of a curb, though. We have draped that curb line, that yellow line is sitting right on that surface.
Yeah.
And it's 5 feet across. And if I want that to be, say the back of this curb to the back of the curb here, then that needs to be 6 inches higher than what it is right now. So I'm going to go to 3D data and change the elevation by differential. And I'll say, okay, I'm going to make that a positive 0.5 this time. Ignore zeros, doesn't matter. I'm going to select that object right there. And it's now sitting 6 inches above where it was. And that's the back of my curb. So how do I build this as a curb structure? And that's going to be those 3D offsets again. So if I offset that 3D polyline with a 3D offset, again by interval, say okay, and the horizontal amount is 1/2 foot, so 0.5, but actually, yeah, let's go ahead and make it 1/2 foot. And the vertical amount is going to be 0, so it's going to be exactly what I had, the same elevation, but I'm going to go out to that side. So that's now the top of my curb, but I need a face of curb down below on the parking lot surface. So I'm going to offset that one by just a little amount, so 1/10, 0.05. And I'm going to drop it now negative 0.5. So it goes down and sits on the surface. And if I then verify all of this stuff with my 3D viewer, let's turn that exaggeration back off. So now I can see that I've done that. And if I load in that surface to sit underneath it, I can see that indeed I have laid that right on that surface. If I look up underneath it, you see how that yellow line that is sitting right on that surface, okay, which was my intent. The original line I kept on the surface, and you could have kept that one and offset up and back.
Yeah.
But I just did it the opposite direction. So either way, that's fine. Now, I could go back and rebuild this using all this data. That's one approach. However, and this is really a good way to build these kind of structures, is you're going to build your underlying surface as it is, and then you're going to build a surface out of just this curb structure as a little intermediate surface, and then we're going to merge that into this other surface. So it's going to just stick it in there and cookie cutter outside around it. Now, if I were to make this into a surface, let's go to triangulate and contour. And this time we're going to change the file to be called parking lot dash island. I think park lot island. And if I said this shrink wrap perimeter reduction, if I leave it as none, watch what happens. I'm going to turn my contouring off for a minute. But I will draw the triangulation lines. I think I have that on. T-mesh, there we go. So if I do that and then just grab these, you see it puts surface information right in here, which I don't want.
Yeah.
Right. So let me erase those. To get around that, I do need to shrink wrap this. I need to provide a boundary around this.
Yeah.
So if I triangulate and contour and I say, yes, I do want to use inclusion and exclusion areas. Now, as it happens, I happen to have a line that I want to use. It's already drawn for me. That's that base of curve.
Yeah.
So I could just do that. Otherwise, I could have it shrink wrap, select the stuff and tell it to reduce the perimeters. But since it's already there, I'll just go ahead and use it. I'll say, okay. And it now asks me to select objects, but it wants to know the inclusion perimeter.
Yeah, that's what I always use inclusion and exclusion.
Yeah, so there's that. No exclusions. And now what I want to do is I want this. And now you see my triangles are contained within what I'm looking at there. And if I look at this just in the drawing viewer, you'll see that, indeed, they modeled right along the face, right across the back, and then across the top. Now it looks like these went straight across. Right in there, but they're actually going up to the edge. You're just seeing in one particular arrangement. See, that goes from here to here to here, and that's sticking out. This is actually tucked up underneath it. So, I would be really confident that everything has modeled correctly with that. Okay, so now I've got that as a surface. And then I can just simply add that in with my triangulation file utilities. I'm going to load up my base surface, which was my parking lot 3. And I can turn this on if I want to look like I had before. I'll go to my next screen and I'm going to merge a 10. And that's going to be my second 10 will be inside the currents, outside translation. I could set these different colors. Yeah, we'll go ahead and leave the colors on. Say okay, and the surface I'm going to add to it is this parking lot island. There's your preview again, by the way. I'll say okay, and now there it is. And because that's the way it will model into this surface, I'm going to go down here to my output section, get the insides, the border, and the outside, and I'm going to do a save as, and I'm going to call this park lot merged. All right, so
How would you your triangles around that curb island like that?
these in here,
Yeah.
and what's the question about it?
How would you basically reduce those triangles in this situation where you're merging surfaces?
Um, I, d- I don't know that I would necessarily worry about reducing them. I would leave them in there. Okay,
Yeah,
I mean, you
that's
could,
a lot of data. You had to, I mean, start adding
yeah,
multiple.
you could do that, but, and I'll show you how, oops, let me cancel that. Let's just exit that. Um, we can simplify that when I'll show you that in a second. But if I look at this parking lot merge, for instance, and that's why I kept those colors on so you can see them as they happen. And there's your contours. And you can see if let's add the line work. So there's my curb lines. And you see how the contours go across it, and they also come down and they taper down the face of the curb
Yeah.
all around until it comes back up. So um, and again, these are every 1/10 of a foot contours, so you can see how they're going to do there. Now, if you remember, this is if I turn on those triangle edges, see those triangles in here? See, they're not really, as far as the surface convolution, they're basically congruent triangles. So they're lying in the same plane anyway.
Yeah, yeah.
If I did need to do that, I could reduce that a little bit with my triangulation file utilities. This time I'm going to load up my merged surface. I'll go to next and turn it on if you want, and you can say simplify. And let's give it a tolerance of, oh, just say just 1/10. You can do it by these three methods, and I would have to look up the help system as to what these differences are. But let's see, edge cost. Yeah, not sure what that would be, but typically an elevation difference. We'll take 4 passes. We'll look for tolerance within 1/10. And so it had 633. All right, so it didn't reduce any. If I simplify, let's try it with an edge cost. And let's see if that does anything for us. No, it's still, yeah, it's
Because those triangles are so flat. Yeah, there you go.
still even with edge cost. Let's see if the elevation. I think, let me unhold that. All right, so it got rid of 288.
Let's look at that
So
wireframe.
with that, you see, and it really pulled them out from over here more so than right in here. It still needed those to define that. It got rid of some. Okay. But in so doing, now if I save that as, we'll call it merged simp. So now whoops, if I view that surface, it's still going to likely be, let's add these other lines. So it's still, now you got a little bit of stuff going on in there, and you can see if I change this shading around, you can see some of it. You see how that now, because it's pulled from here, you see how it's warped.
Yeah, yeah.
It's warped some of this. It got rid of some of those, and it considered it within that particular tolerance value that I gave it. It relaxed some of that hold, and so it reduced some of these. Now, overall, if I'm really looking at a 1-foot contour, and I look at that, that might be, all I really cared about. Let's make this at least a 0.5, So that gets the gist of what I'm doing in terms of a contour map. But again, in terms of the surface, which is what you're going to be doing, because you're going to put that on the machine and go out there and grade it, then you have to weigh whether that little bit of savings, which really muddied up that, from the difference between that file and the preliminary, or the, not preliminary, let me come back to, oh shoot, let's see. Skip that. Parking lot island is 153K versus the simplified, which is 28K. So now, very small site. So if it's large, you're going to look at, well, I've got 14 megabytes on that thing. It's not going to fit on my machine very efficiently. So that might be, and this one might turn down to be 5 megabytes. Well, that might be a difference you might want to work with. And then in reality, those little differences, when you're out there in the parking lot and grading with the dozer, even though your triangles are going to try to put in that little bit of convolution, you're not going to really see it.
No, you're not.
The gravels that you put down on top of that are going to stick up and make up that difference. So
yeah,
those are all just sort of judgment calls you can see. And my recommendation would be to keep your surfaces as complex as you can without them being unnecessarily complex.
Okay? Yeah.
And so in that particular case, that gave us that. So if I look at this, and I'll show you another example here. If I go back to my parking lot merged, let's set up my contour interval back to, let's just say 0.2 maybe. All right, so there's a nice little surface. It's nice and smoothly defined out here in the parking lot areas. It steps up and over and across the back of the curb nicely. But I do notice, that island is just, it's dead flat. It's not level, but it's dead flat edge to edge across the surface. Okay, so one of the things that I would do in that case, let's say, well, I'm going to draw in some ridges into that, because this is going to be mounded up a little bit. So I'm going to just draw this little 2D line, and I'm going to go from the center of that. I'm going to go from the center of that circle to the center of that circle. And I'm going to go from the center of that circle up to the midpoint of that one. Now, those are at what elevation?
0 right now.
They're 0. If I'm going to put them anywhere, where am I going to put them?
I mean, you could drape them to that surface.
Exactly.
Yeah.
Exactly. That's the answer I was looking for. So to do that, I'm going to do what? Right now it's 2D. I need to make it 3D.
You go to your 3D data, 2D to 3D by surface.
By surface model. Exactly right. Now, it doesn't make any difference whether I do this on the merged or if I do it on that parking lot island, because that is the same right in there. Right.
Yeah.
So I can just do it on parking lot merged, and I can now select these lines to convert. And I'm going to apply a vertical offset at this point. I'm not going to keep these existing ones, but I will set the converted polylines to be on my break line layer. And I'm going to give it a vertical offset. Let's make that say, 0.3 higher than the existing ground around it. So I'll say, okay. And so now there they are. And if I look at that in 3D, to verify. You can see how it's raised up. So that's now raised up above that surface a little bit. And I would just go right back to, I will go triangulate and contour. And this time I'm going to write, and I'm going to put this back to be my parking lot island file. Use inclusion exclusions on this and overwrite. I'm going to find my inclusion line. No exclusions. Select the data. I now have the parking lot island again, and I'm going to go right back to my triangulation file utilities. I'm going to load up the original parking lot 3 as my base. I'll go next, and I'm going to merge my parking lot island and save that as parking lot merged. It's saved. I'll exit that. And now the final result, looking at my parking lot merged, it's now, and again, because I've got my contour interval set to be, so large, I've got that, but you can see it has actually created as raised ridge lines. And you can see that ridge line went from that center all the way down to that edge, and it formed all of those, and it dropped in a point every 5 feet because we said densify the polylines. But when I go back out to my drawing, well, those actually have points along them because they've been across the surface. The original 2D lines would not have been there. But it did when I said 2D by surface model. Oh, it's not what I wanted to do. Let's see. Yeah, I didn't know if I was going to get this dialogue or not. That's why I wanted to not mess up my other line. So this is where add vertices at grade bricks. Excuse me. If you don't turn that on, it would only set that endpoint on the surface there and the endpoint over here, and it would not set a vertex as it
Okay.
triangles along here. Okay.
Yeah. I got you.
Now, why that is important to do sometimes and sometimes not is, for instance, if this represents a water line,
Yeah.
put that water line 4 feet under the ground. Well, I might want to drape it on the surface, but only put it on the endpoints and then drop it 4 feet below. Otherwise, it's going to try to make that pipe have all those bends in it.
Yeah.
So I would just put it there and drop it down, 4 feet and have it go from there. So, always look at those options on those dialogues and ask yourself what they mean and what they do. But that's the way that I like to build these surfaces, is you build these in little pieces and you merge them into the composite whole. And if you come back to our book here, and if we go to something like this, I would use the tools that generate all these things that you see in here. These are all just generated 3D lines that come out of these grading tools. I haven't built any surfaces with them yet, but then I would build maybe this building pad surface, maybe this parking lot pad surface, merge them, or, take this entire thing here once I resolve this conflict, call that a surface, and then merge that into the existing ground surface for my composite total. So, tackle these things in pieces. And that's the same way we did in this upfront set of exercises, called putting it all together, when we generated a surface. You see the blue and red contours here?
Yeah.
That's that existing stockpile. Then we decided we're going to make this into a borrow pit. We just drew a 2D polyline and we set it at a particular elevation that we told it we needed to have so much volume taken out of there. It went up as 3-to-1 side slopes, intercepted this surface that set this outside boundary, kept this down at that elevation, and then just drew these lines. Well, then I selected this, made it into a surface called borrow pit, and then merged it into these blue and red contours called the stockpile. So there's my stockpile. There's the borrow pit, and there's the result of merging that one into the other one. And also by keeping them as separate contours, I can contour the original stockpile with existing contour layers and styles, and then I can contour my designed surface here of just the borrow pit as proposed contours. So that right there is my grading plan, okay? Because I kept the surfaces separate. I could also then, combine. I could take the boundary of the borrow pit as a trim line and trim the contour work out from in between it, and that's just trimming line work. I haven't touched the surface there. If I were to contour this as a single surface, I would have these contours would all show the same style.
Yeah.
But that's a nice way about approaching this in pieces. And you just have to sort of mentally keep track of the different things that you've got going on and whether or not they make sense to be merged or whether you want to keep them as separate items. Okay.
Yeah.
So that puts us again, we've sort of scooted past our break time. Let's go ahead and take us a little 10-minute break and then we'll
I'm gonna switch. We just got power back. So I'm gonna switch the internet and then my computer set up here back over to land power.
Yeah, that's no problem. Yeah, just drop off and rejoin, and I'll see you at 10 till the hour.
All right, perfect.
All right, see you in a bit. Zoomer. Okay, so a couple of things I want to point out, just for you to sort of keep in your back pocket as well. If you're going through this manual and that upfront set of stuff, tying it all together, there's this step 5 where we talked about, I showed you how we trimmed out the existing contours from within the footprint of that borrow pit.
Yeah.
And there's 2 ways we could have done that. We could have gone to our edit, erase by closed polyline. If we had drawn around the edges of that, all right, that's one way to do it. But what it's telling you to do here, and this is just illustrating one of many ways, is we erased all the contours and then we drew back that surface and we only drew we did this draw triangulation lines. So it drew all of those in there for that one surface. And then we looked at each of those, but each one of these little line segments was an individual line. And we needed that to be our boundary at some point. So we could have said join nearest and picked our way all the way around it, or we could have, in this case, we did a shrink wrap, but chose bounded line work only, and it did a complete single line around everything. Then we erased these triangles and we used that line then as our exclusion polyline, and we drew the original contours again using inclusion and exclusion. We did the original inclusion, and now we chose this new line as an exclusion, so it didn't draw inside. Or we could have taken that and drawn all of the contours and then drawn with that command erase by closed polyline and erased on the inside. That would have affected the very same thing. Now, the other thing it's telling you here, and this is what I wanted you to keep in mind, when it said, we're going to go to the surface menu, contour from tin file. We did not draw the contours, but we did go back to the triangulate tab and we said, draw the triangulation lines. And then we did a shrink wrap. Okay, so one of the things that we could do otherwise, you could go to the surface menu, and instead of contour from and set from that way, you could draw a surface, draw the triangular mesh, do those the same way there, or even better, just simply draw the surface boundary, and that would have drawn that outside edge of that surface directly without having to do a shrink wrap. Okay, so any and all of those means are possible and correct. Probably the quickest, if you need that boundary for any particular reason, is just go to the draw surface boundary command. Okay.
Yeah.
So, little things like that. Now, how familiar are you with the grading tools such as, in particular, I'm thinking of this design pad template?
I don't have any experience with that, and I'm actually I'd kind of like to learn about that.
Yep, that's going to be that's going to be our primary grading tool. So let's get to a little bit bigger surface, a little less simplistic thing here. So let's take a look at a couple of things here to wind up the day today. If we, well, I tell you what, for right now, let's just illustrate a couple of things. I'm going to take this parking lot island out of here. We're going to work. Do you have that parking lot 3? Do you have that nice smooth parking lot? Where we set that once. We've got the, did you have this surface here in these? Did you wind up getting that generated?
I didn't even build that. I've been kind of taking notes and
okay. Okay, yep, that's perfectly fine. So so let's generate some working stuff here to start with.
Okay.
Let's close this file. You can save it if you want, but let's open up now a file. And it's going to be in your getting started folder. Some projects. And it's going to be called Sample from T3 Global. I'll go ahead and open that. You can ignore missing shape files. And we have, this is actual data from a photogrammetric job done here on the Pennsylvania Turnpike out in the middle part of the state. So this is what they use to create this contour map. And if I'm going to freeze off these, this is the delivered file. You see their contours and spot elevations, and they've got some obscured area contours over in here that are shown in a different style, all that. There's a bunch of points and things.
Yeah.
So what we're going to do is we're going to recreate that surface. Now we happen to have all of these compiled break lines, and it's on a layer called V Topo BKLN. Okay?
Yeah.
We got those break lines, and we've got a number of just CAD points. You can see I've selected them there. If I'm down here to my point style, if I turn my points on so you can see them, there's your AutoCAD points that are part of this. Okay, that they used when they compiled this data. I'm going to set those back to the default of a period, or just a dot. So there's so we're going to build the file. Now we're going to go over some of this stuff tomorrow and what you do if all you have are contours and how do you fix some of the problems that you're going to get into that. But we'll do that part tomorrow. But right now, go ahead and load this file up. So you got everything loaded there?
Yep.
All right, now we're going to isolate the two layers that we're going to use to build this surface. And we're going to go to our view menu and choose isolate layers. And we're going to pick one of those little white lines like that. And then we're going to zoom in and pick one of these little purple dots. So now you should see something like that. And that's really all that we have. And in fact, when we look at that in 3 dimensions, this really is no different than, in fact, in a lot of ways, better than a contour map in terms of representing that surface, because it shows you everything about that surface in terms of all of the break lines are there, including the curb tops and bottoms. And they are rolled wedge curbs, so they don't have that 6-inch drop. It's a triangular shaped curb.
Yeah.
So anyway, everything's there. That's all we need to build this surface. Now, we will need to do a shrink wrap, because otherwise you're going to get these long skinny triangles over here in these inset areas, like in here and down here along the bottom. So if we don't do it, I'm going to unsave. I'm going to undraw contours. I'm just going to draw the lines. Oops. No exclusions. So if we were to not do that and just draw the contours, you see, I'm going to exit that for a minute. So you see these contours out in here, or these triangles, don't make any sense. Those are the ones we need to get rid of, which we could do and erase triangles, but we're going to do it with the inclusion. You said you already do that kind of stuff.
Yeah.
All right, so what we're going to do is we're going to shrink wrap this data. Now, what do you normally do to shrink wrap your data?
So I go draw,
You do a draw shrink wrap?
shrink wrap entities, and then
Yeah.
I usually do it on a perimeter. I call it a perimeter layer. And then depending on what I have, I adjust my gap size, my max gap distance.
Yeah, well, there's a couple of things you can do with that. You can do that directly. You can actually do it as part of the triangulate process now. Right down here, if you uncheck that, it's built in right here. Shrink wrap perimeter reduction, and that's where you set that reduction. Now, we're going to say we're going to use it, and we're going to draw it first, because if you're used to doing that, there's a lot of usefulness out of this command besides just what we're talking about. Now we're going to have to go across gaps because we want to shoot across these open gaps out here in the edges.
Yeah.
So, and we'll put this on a layer. I'm going to put this on a layer. I'm just going to call it BDY. Maximum gap can be whatever we want. And here's the differences in how this works. And I'll tell you what this means. They call this a perimeter reduction, and that doesn't really tell you much about what is going on. But here's how this works real quickly. If I say no reduction, and I say, okay, and I grab my data, then there's what it's going to do. It didn't reduce those. So it would have included triangles in here because I did no reduction on that perimeter. Same thing down here, it would have included those. So I'm going to get rid of that one. I'm actually going to change this BDY so we can see it when the time comes. All right, so now if we repeat that command, shrink wrap polylines, and we change it from no reduction to high reduction, and we do it this way, you can see that it comes in and it really gets convoluted in here. It pulls down. Now, like normally when it came down here, if I said, no reduction, it would have just gone on the outside. So what's really going on is this. And here you can see the result of a high reduction. It pulled way in as it came back out. So what's happening when it runs that command, it's actually triangulating it in memory in the background. It's looking at those triangles, and then it's doing a erase triangles from the outside edges, and it's doing it according to what you set. You say no reduction, it doesn't get rid of any triangles. You say high reduction, it gets rid of as many as it can, including in areas like this where you might say, well, that's legitimate surface in there. It just went in too far. Okay, so if we do it, and there's the other options are, this time we'll set that to low and what we saw earlier. And now you can see up here, it didn't jump way down here and come back out. It did come in a little bit. And then if you find out that you need to adjust it later, like you could add a vertex into there, you could remove that vertex, maybe remove that vertex, remove that vertex. So you can adjust this as you need. Same thing there. There's another command that's quicker than that called erase, and it's on our polyline menu. It's this polyline remove, polyline vertex. We select our vertex, and then we just click near the points that we want to have it removed. And let's say we wanted to get rid of all of these points down in here. So it lets us sort of fine tune our way around some of this stuff. You can do that. You can also do a add polyline vertex, which would be this command. We choose the polyline, and now we're going to say put one in here, one in here, one in here, one in here, and sort of work your way around it. You can do any and all of that kind of stuff. The other thing is that there's no reason why you can't simply draw a polyline. And you say draw to the polyline, we'll put that on that same BDY layer.
Yeah, I do that.
And you can just
Here and there.
yeah, you can do something like that. Well, see that close. Come on. Anyway, the point is, it's just a polyline, and you can do it any way you want to create it. You can draw it yourself, or you can use shrink wrap, which will help get it a lot closer as well. And I hope I
like that. I like that remove polyline vertexes. I like that.
Yeah, it's nice.
Rather than, I mean, I don't even want to tell you how I was doing it before, but
Well, you can do it by grip edits and hovering over the grip and remove polyline, or you can do a P edit and smooth and all those kind of things, but they take time. And so
yeah.
that's just one of those Carlson locations. And I think I have managed to lock this up. All right. Bear with me. That's why I like IntelliCAD.
I no, that's not. This is like a daily thing for me. I don't know what I do, but it just doesn't like what I do.
So here I'm getting started. My sample from T2. There we go. Those on. And now I'm going to do a save as, and we'll just call this one. Stay there with the color grading. All right, so any way that you want to create that would be fine. If I shrink wrap across here, I'm going to do a low reduction. And I'll adjust it if I see that I need to, like I could smooth out some of these. But there's no need to worry about that. So in fact, what these guys do, if you see the remember those contours? Like there's those contours, you see, they only go up to that certain edge here.
Mhm.
So what they do is they compile all the way out to the edge, and they offset a line like 50 feet in, and that's where they cut their contours off. So that's one of the techniques that they do. Oops, let me put down and down and down. All right, so I'm going to I'm going to convert this to an arc and bring that in, tight it like that. All right, so there's going to be my boundaries, and that's going to be fine. I'm not worried so much about it, but I'm not going to have those invalid triangles. So now let's go ahead and build our existing ground. So we're going to go to surface, triangulate, and contour. And we're going to write the triangulation file, and we'll hit select. And we're going to, oh, come on, AutoCAD. I'll wait for AutoCAD to wake up again. Anyway, we're going to give it a file name here, and we're going to put it in there, getting started surface, and we're going to call this one TPK-EG. That's Turnpike Job Existing Ground. Okay. We will use the inclusion exclusion areas this time because I have it drawn, and our choices are to either remove the whole triangle that crosses it, or we're going to trim the edges at the boundary. That's our better choice. So we'll go all the way up to the boundary. We will Ignore any zeros. There's no real need to densify those lines, but let's go ahead and turn it on and give it a 10-foot densification just for giggles. And then make sure on the contour tab that we do not turn on our contours. We're going to have their drawn contours that we can use if we need them later. And make sure on the selection tab, there's no filtering going on. And we're going to just use all the data that we find. Right now, we've just got those 2 layers. We've got the boundary. We'll say okay. Read our prompts. It says select the inclusion perimeter. So there's that. And then any X or one found, I'm through selecting inclusions. You can have multiples, so you can have different pieces in one file. Now any exclusion parameters, and in this case, we had some things like these building outlines that are on a different layer. We didn't we could include those, and it just puts holes in our surface. But for now, we're just going to say no exclusions. And now everything that we want to triangulate, we'll just grab it all. Hit okay, and you're going to get some errors that are going to pop up, and they're going to be a couple of things. Here's one that's 3/10 apart, and we can zoom down to it and then zoom in. And it happens to be a little head wall around a culvert that they have some crossing break lines on. We would normally in the fundamentals class, we would work on straightening that out. We're going to just let it go, let it resolve it. Here's a slight vertical edge. Over here, you can see it's where one of those break lines actually crossed the curb line as they compiled it. Same thing, another one here. It's just where it's where the curb line dropped down. They've got a slight little vertical differential there. Right now, we're not going to worry about fixing those. We're just going to say exit, and it's now has built the surface. We can do a 3D view of the surface file. Boy. Probably time for me to restart my Windows system. There's my TPK VG. So tab contour interval back up to 1. But so that looks like those contours that they delivered is exactly what we'd expect. And there's a little retaining wall over here that you can see right in there that models pretty nicely. And there's some problems. If we were to build that surface from contours, we'd see all kinds of problems on these road gutters and on this this loading dock area. These retaining walls over here, you wouldn't see those show up correctly. But because we use the break line data, we've got a really good existing ground to start with. Okay.
Yep.
So we got that one built now?
Yep. There.
Okay, so what we're going to do is we're going to draw a little building pad over here, and we're going to use this design pad template and show you what it's going to be involved with. So the way we would normally do that, let's just draw a rectangle. Let's draw a rectangle. And let's just arbitrarily pick something like that, right in this area here. Now, it is set right now at 0 elevation. And we can put that, we can do one of two things. We can drape that on the surface. Let's say we're going to, design a pond or something here. We could drape that along the surface and then say, go down at 3-to-1 side slopes until you hit a bottom elevation, and it would draw all that stuff in there for us. Okay, but what we would normally do, like if you're going to drape that, you would go to your 3D data, 2D surface model, choose the surface, choose this, and tell it to put it on the surface. And you can say, put vertices at everywhere it hits a grade break or not, in which case it would only set the corners. Okay, so that's one way of doing it. Now, the other thing we're going to do is once you've drawn that rectangle, just leave it there. And let's go back and turn on all the layers. So we can view and say thaw / on all layers. They're now on. And now we're going to view freeze layers by pick. And we're going to pick one of those squiggly white lines and one of these pink dots to sort of get them out of our way. And now we can see our existing ground is like 1315, 1310. So we can get an idea of where this really sort of needs to be. Okay. Because let's say we did have this and we set this elevation to be what, there's 10, there's 15. So that's 12, 13, 14, 15, 16. So about midpoint looks like 14 and a half. So if I select that and change its elevation and its properties to 13, 14.5. Okay, so that now is sitting at that elevation. I look at it in my viewer. And I see that I've set that at about that mid elevation. It's high on this front end, but it's low on this back end. Okay, so we've sort of set it on neutral ground, but it's still flat. And now, if you were doing this sort of the manual way, let's say you're going to build it as a building pad, what could you do to create, like, where would this tie out? If you're going to put 3-to-1 side slopes on this thing, what's one thing you could do with it? That some tools that maybe you've used, if any.
I don't know. I don't know in Carlson.
Oh, okay. So one of the things that we did before with the curbs, remember that 3D offset?
Yeah.
So if we did a 3D offset, and this time instead of going by an interval, we're going to go to a surface. Okay. And we're going to set our projection to be perpendicular to our polyline this time instead of the slope direction. There's a subtle difference there. We'll talk about that tomorrow probably. And let's say, now we no need to reduce those. Let's say, okay. And now we're going to round the exterior corners, yes or no. Let's say yes, so you can see what that's going to have happen. And we're going to go by a ratio. So R for ratio. And we're going to select this polyline. Okay. And we're going to target that surface. And if it's in fill, it wants to know what ratio. I'm going to say 3. So 3-to-1. And if it's in cut, I'm going to also do 3-to-1. Okay. Now, which side, inside or outside? Let me go to the outside. So now I've put this line here and you see it touches right there where it intersects that surface. So if I were to look at this stuff in 3D, you can see how that offset line actually went up to that surface and then went down and caught the surface all on the way. In fact, if we add in that surface, So now you can see the original building line. You can see where it sticks out, but it gets buried back here. But you see that line that we draped on the surface is out there on the surface.
Yep.
So that's usually enough to be, and then I could take these two elements and build a surface out of that, just called my building pad, and tell it to densify the polylines, and it would do all that stuff for me in memory. But, and that's one way to do it. And I'm going to select that line and get rid of it. But the other way is using this design pad template. I'm just going to make a building layer here so that we're let me give it a little lighter color. I'm going to set that on building. There we go. All right, so there's another way with this design pad template that it's got all kinds of additional tools to it, and we can always do that with that 3D offset. And notice that when I did that 3D offset, it didn't have to simply be an open-ended line. It took that closed figure and it went out. It could have gone to the inside, it can go to the outside, and it created the intercept of that surface. So that is a legitimate way of doing it. But if you do this design pad template, so go to surface and choose design pad template. There's a lot of options here that can do a lot of things for you all at once. And so now it wants to know the source of your target, either a surface file or screen entities or a specific elevation. So we're going to go to a surface file, and then it asks, all right, what direction from a closed pad, inside or outside? We're going to go to the outside, and we're going to go perpendicular to the pad polyline this time. We'll choose ratio. So notice these are all the very same things that we had in the offset command. And then you can have it go ahead and merge into that surface underneath it. You can do all kinds of things together if you want to, but we're not going to merge it. We're just going to keep it separate. In fact, we're not even going to compute a surface yet. We're going to just look at the geometry when it does it. And you see this thing right here that says process multiple pad polylines. Remember our little example back here of this guy here, right? You know, this was an example of using that multiple pad polyline. So it took that building perimeter and it took this parking lot and it did them together, and they generated that set of graphics. Okay, so that's what this multiple pad polyline lets you do. If you do it, then you set up and you choose the layers that those are on, etc. Okay, so you can do these and even use a separate surface for the interior side of the polyline. You can offset them both at the same time. You can have different slopes for different sides. Like this could be a 3-to-1, these could be a 2-to-1, 1.5-to-1, something like that. If you know in cut that you can have a different slope than in fill, you can set those up as well. Rounding the exterior corners, if you do that, I'll show you what that means. Go ahead and check it on. We're going to uncheck, calculate the volumes, and calculate the surface. And we will say erase previous pad entities so that we can try this in different ways. And we'll set our pad polyline spacing to every 10 feet. Our corner delta angle to 10 degrees. We'll leave shrink and swell factors at 1. You set a subgrade depth, the topsoil depth. We're not going to fool with any of those right now. And trim the existing contours inside the pad. We're going to say no, otherwise trim these off. And we're just going to put this on a layer called PAM. We'll just leave it there. And that's all we need for right now. Now, if you did one other thing here, this slope pad design, this lets you set a cross slope on the pad up front so that it will actually slope that pad for you. Okay?
Huh.
But for now, we're going to uncheck that. We're just going to leave it level. And we're going to say, okay. All right, now looking at our prompts, it says pick the pad polyline. So if I pick this pad polyline, it's going to then go through and look at the surface and tell us what's going to happen here. Oh man, I probably should have just restarted everything. We're so close to the end. All right, so it now wants us to find the surface. There's that surface. And it says, okay, it went ahead and loaded up the triangles and it wants to know the fill slope. We'll keep it at a 3-to-1. Cuts will be 3-to-1. And now it wants us to know if we want to adjust the parameters and redesign it. Well, if we're happy with it the way it sits, we would say no. Otherwise, it would take us back through it. Now, if I said, I just like no, contour the pad, I'll say no for that. And all it's done is created these as 3D lines. Now, there's the rounded corners. Otherwise, it would have gone out here and intersected these at a sharp point. So we wanted that to be rounded as it came across those corners. Now, this side polyline spacing in the dialogue, that was at every 10 feet. And when you see blue lines, those areas are in fill and red lines are in cut. And there, this line right here is that very same thing you saw with the 3D offset that we did earlier. All right, so that built us that little set of geometry. Right now, we did not make a pad out of it, but we, not yet as a surface, we could do that by, isolating these layers, selecting all that kind of stuff, and building the surface, merge it into the original, all those kind of things. But now, one thing that we can do, however, and one thing you didn't see because I was waiting on the prompts is normally when you pick that polyline, you probably saw it on yours, it tells you what it should ask you for the elevation of that. I'm not sure that it did or not. I mean,
No, it didn't ask me.
okay. So I'm going to erase these polylines. I'm just going to pick one of those lines. It's going to be that layer pad. And I'm going to do that. Maybe, I think the reason it did that was this, because it already had an elevation. If I set that back to 0, now when I did that little tool up here, that was from my layers toolbar, and that was edit, erase by layer. And that let me pick that line, and it took everything on that layer off. Now, if I were to repeat that pad polyline, or design pad template rather, this time now it should ask me for the elevation. If I pick that, it's going to wait and ask me for the surface. Surface. Now no, it's still.
Mine didn't ask me either.
Here it comes. Because it's 0, it tells me that, okay, the range of the existing elevations all along that pad go from 1311.66 to 1317.22, and it's asking for an elevation. It defaults to the minimum, so that would mean everything's going to be in cut. So, we could do it that way if we wanted, or we could give it a specific elevation. In that case, we had that 1314.5. Let's make this one 13, say 12.75. Well, it doesn't matter.
So that elevation it gave you would be the balance elevation?
No, no. The elevation it's suggesting is the minimum.
Okay.
So that would put everything in cut.
Okay.
So if I do that, now it's more in cut than it is in fill. And if you said, yes, you want to adjust at this point, you could change those slope parameters, elevation of the polyline, etc. I'm going to say no. I'm going to not contour. And so now that would be what I can make a surface out of and go from there. So it's just a little fill, mostly cut. Now, if I needed to balance that, that's going to be on my surface menu, and I'm going to edit the pad template, not design it. So I'm going to choose that, and I'm going to choose that green polyline. That was the pad. And this is what I had set before. So I could change the side slopes. I could change that elevation. I can even move the pad. So if I move the pad, say from here, just move it slightly over to here, and then process, it's going to take those same elevations up here and do that process. Notice that if I want to get a report, I can see my cut and fill. There's 900 yards of cut, 167 yards of fill. And you see that right in here. Okay, you've got your target surface. You can change that, do all kinds of things with this. And you've got this balance button. So if you balance.
How did you get into this menu here? This one? Was it under
Surface?
Yeah, surface.
Edit.
Design. Oh, edit. Sorry.
Pad. And you choose our pad. There we go. And so you can do, you can move a vertex. Let's say we wanted to move this vertex out to something like this. And then we hit process, and it's going to recompute that. Okay. Now, when you choose balance, you set in a tolerance, and you give it how much you want to bring in. So if you, or how much you want to carry away from this. If we set it to 0 and say, okay, notice it recomputes and it resets the elevation up here to what it would be to achieve balance. And if I do my report, I now see I'm within 10 cubic yards of being balanced, and basically 500 yards of my balance condition. And you can set that tolerance. If you say balance, you could change that. Instead of 10, you could say, it's the nearest cubic yard if you wanted, and say, okay. And now it's 502 and 502 at this elevation, and we compute it. Now, suppose, all right, that's a balance condition. It matches cut and fill, but if this were a borrow area and I needed, 20, if I needed, say, 5,000 yards of dirt over on another part of my site, well, I can just hit balance. And I want to say, I want to carry out 5,000. That's my export. If I say, okay, then, okay, it drops it to this elevation. It's all in cut, but that amount of earthwork would be this 5,000 cubic yards that I need over on another part of my site. Okay. So it's a nice way to, to fine tune your grading just from this editing. And then you can write a 10 directly from this, or you could separate, and isolate the layers and just build the surface and, keep all that stuff separate for you as well. All right, so let's go ahead and write this 10, and I'm going to call this, once it comes up and asks me for it. I'm going to call this surface. I'm just going to call it pad. I really apologize. I should have restarted my Windows stuff. There's something hanging it up right now. All right, so I'm going to call it pad. And off it went. It's created that surface. I can now exit that. And I would show you that, but it's going to wait and ask me to, take forever to load the file up. Trust that it's there. I've got a surface called pad. It goes out to this outer edge. It's there. I can merge it. I can do all kinds of things with it. But now here's something that we might want to do. Let's say we have a 2D polyline. I'm going to put this on a layer I'm going to call ditch. And I'm going to go from, say, here down to this corner. And right now it's at 0 elevation. It's just 2D. I can go to 3D and say 2D to 3D by surface model. That's one way I can do it. Or I can draw a 3D polyline. And this time, instead of prompting for that slope, I'm going to say use a surface model for my elevations. I'll again put this on ditch. I'll say, okay, now I'm going to, once it asks me for the surface, I'm going to use pad. And so it's going to tell me what that elevation is. See that little box up here?
Yeah.
Where I am. So right up in here, that is that 1308.51. That's where it wound up. So I'm going to go from here and I'm going to come down to here. Wait, pick a point or point number. I just want to pick. I don't know why it's finding something there. So now if I look at that, that has the elevation of 13,851, 13,0851. So it's sitting right on that surface, which was level. Okay, so what I'm going to want to do is I want to turn this into a 5 or a, let's make it a 5% ditch that's going to start up here at the surface and it's going to go down at a 5% down slope, and then we'll put a pipe and run it under the ground to get out outside. I'm actually under the ground down there anyway because I'm in cut, but let's say I'm going to drain this. I need to make that a 5% downgrade line. I've gone ahead and set it right on the surface here. And so I want to set that slope. Now, on my 3D data menu, I can set, I could do a number of things. I could draw a 3D polyline, snap to that endpoint, give it a 5%, tell it to go down. But I can assign these, the polyline elevation editor. That's what I'm on. Is I'm going to pick this polyline and I'm going to change its elevations. So it selects it and it puts me in this little editor. And right now it's exactly the same. But to set this, I'm going to check the number 1 vertex up here because that's going to be the one I'm going to hold. But I want it to come down to here at a particular slope. Right now it's flat, so I'm going to make that at minus 5%. I think the percent's already in there. I have to look at the settings here in a minute. Let me go to my settings button. Slope mode is in percent. Yeah, there we go. So I could have just said minus 5%. So now to go to minus 5%, it's going to lower that to 1299.7534. That's what I want. I'm good. I'll say okay. There's all kinds of controls and things in there that we can use to set like wall elevations and all kinds of things. So now this starts at the surface. It goes down 5%, so it's below the surface. Now, just like we did with the parking island in the parking lot, we're going to make this the basis of a little ditch. So if I want this to be a 2-foot wide ditch, 2 feet across the bottom, and then I'm going to side slope it out to the existing ground at a 1-to-1 side slope on my ditches. So I'm going to offset 3D, which was my edit 3D polyline utilities, offset 3D polyline. We're going to go by interval this time. I'm just going to set the bottom width of my ditch. I'm going to say, okay, my horizontal offset will be 2 feet. My vertical offset will be 0. I'm going to take this, I'm going to go over to here. So now there's the bottom of my ditch, and I'm going to climb out of that bottom till I hit this pad at a 1-to-1. And I can do that continuing that same process with 3D offset if I wanted, or just like we did the pad, I can close off these ends through the whole thing and it would come back out on those upper ends, or I can do it one side to the other. Let's do just, instead of the clothesline, let's also go back to our surface menu now and design pad template. We're going to choose a surface file, but let's make sure we uncheck to erase previous pad entities because we don't want to erase these out here. And I'm going to now put this on a layer called ditch dash grading. And so I'm going to pick this polyline, and the surface I'm going to target whatever comes up to me. Is my pad surface. Come on. And instead of 3-to-1s, I'm going to do 1-to-1. Now, which side, because outside or inside doesn't apply, it's not closed. So I'm going to go to this side for that one. And I'm going to no adjust, no contour. I'm going to repeat the command on this other side, choosing pad, 1-to-1. Set this side, no adjust, no contours. And now I could shrink wrap that and create a surface out of that particular entity called a ditch, merge it into my pad, and you would see the resulting difference. So if I said, let's triangulate and contour, and this time I'm going to change the file. On we're going to call this one ditch. We will not use the inclusion. We will say no reduction to let it do the shrink wrapping. We'll say okay. And now we select the things we want to include. We're going to get this and this and these guys here. Let's see if I can get a little more of those. I don't need that. These. Normally I would have isolated the layer. All right, so that now has everything. Off I go, and it built it. So, so I've got that surface now, and I'll do it in 3D. Man alive. So there now is that ditch. And there's the contours shown at 0.1. Let's just do a 1 foot contour. Well, maybe that was 1 foot. Okay. So there's the ditch that would be in the bottom of that. If I add on top of that my pad. You can see it there, and there's the ditch underneath it. And if I make my pad a little transparent here, you can see that ditch sitting underneath it. And if I were to merge this into this pad, you see it would wind up being that composite surface. So we'll just remove that out. So if I were to go back to my triangulation file utilities, load up my pad, good Lord. Load pad. Go next. We merge. Ditch. See what that would do. I'm now going to save that as my pad ditch merged. It's now there. I can exit that. And one last trip to the viewer if it lets me. So there now would be that resulting surface. All right. And all that's done the way I was telling you about. If you do this in chunks, do this in pieces, then that's going to, and you can see you could do the same thing by merging this resulting surface into that existing ground, and that would be your total final surface. Obviously, you can calculate volumes. So if we go from apologies on my Windows misbehavior here. It's put some interaction due to Zoom and everything else, so I just should have restarted. So if I went from the pad and compared it to the ditch, for instance, no inclusions, no exclusions, leaving everything there. Here's I've got 6,000 cubic feet or 200 yards of cuts to dig that ditch. No fill, obviously. Okay. Now, a couple of things. If we're looking at this report, right in here is a really good summation of something you can use to help balance a site. Let's say, pretend we did the overall everything compared to this pad and ditch together. I'm not going to go back through waiting on the files, but it's going to compute this average value here and tell you how much you need to change the elevation of your final surface in order to make it balance. So if I were to raise that surface 3.191 feet, the cut and fill, or in other words, that if in this case, the ditch, if I brought that ditch up out of the ground 3.191 feet, it would at least come close to balancing here. That's the average difference. And it tells you how much change per tenth of a foot height difference you're going to get out of these volumes. Okay, now that's a good number to have as a contractor, because I had a project I did up in New York State, excuse me, for Lockheed Martin. We were designing the site for, they were building a new helicopter maintenance facility, all these helicopter bays. They were going to get all the electronics for the president's helicopter.
Hmm.
And the architect involved there, we did all the modeling, did the surface modeling and got everything ready. And we had a certain amount of earthwork and everything set. And the architect said, well, that's good. It said, but, as you approach the site, driving up the road, it's sort of sitting down low. Can we just raise that site up a couple of feet? And the contractor said, sure, yeah, we can do that. And so that'd be $4 million. And
Yeah.
he goes, what do you mean? He goes, well, 2 feet, that's, he knew this number right here.
Yeah.
And he knew that if he had to raise it 2 feet, well, 2 feet is 20 of these 0.1s. So it's going to be in his, whatever that number was. And he knew how much it cost him to move a cubic yard of dirt. He knew that number, multiplied it by 20, and came up with that $4 million cost. And so the architect thought, oh, you could just raise it up and it'd be no big deal. I said, yeah, you raise it up, you've got all kinds of additional fill, you've got, all this stuff going on. And that's how much change it's going to be. So that's a really good hip pocket number to take into meetings with you, to know those numbers.
Yeah.
So that's just some of that detailed information that you can get on that. But the bottom line to the grading stuff that we're doing here is that we are generating 3-dimensional drawn geometry. As you saw, when we look at this in 3D, in fact, let me do it without trying to load that up. I'm going to have to wait on stuff. So if we are, we are going through the tools necessary to create that drawn 3D geometry that we then use to make surfaces from. Okay.
Mhm.
And that, knowing those tools is going to set this stuff up so that then when we go to build this, we just put these in as surfaces. And you can do those as independent little individual surfaces, or you can merge them together, whatever you need to put on your equipment to go out and grade these types of entities. So, so whatever means are necessary to do, we can draw a 3D line, we can calculate it separately, or we can put it on the surface. We can use that design pad template, which has all those other tools in it and adjustment tools, so that we can do all that stuff without all that extra calculation, get that drawn edge work. And again, it's just drawn 3D lines, and we use that to build these surfaces with, and we're, half of the battle is won. Now, real quick, just to let me show, and then we'll wrap it up. This SiteNet menu, or things like this layer for that pad, for instance. If I define my material surfaces, I've got existing, I've got design. So my existing, I had a layer called V topo break line and V topo spot and V topo DTM. I'm going to move that to existing. And design, I had my ditch and my pad. I'm going to move that to design. All right, so I had these particular items. Everything else is other. And so design, now let's look at that pad. If I double click that and edit it, I can, well, my pad's going to have, let's say, I had a sub base. Let's just call it stone. And it went down 8 inches, for instance, and I could put in a cost per square foot, per ton, for whatever it happened to be, and come up with dollars. And then maybe under that, I had a layer of sand that only went down 4 inches below the stone. You can do the same kind of thing. And then when you run that, you would save that, and then you would run these commands. Now turn those back on because they were included in the display. But when I excuse me, if I go to calculate these volumes, then, well, first I'd have to make the existing ground out of the things on that layer, make the design out of the things on those layers, and then I would calculate these volumes, and it would take into account that 8 inches of stone, 4 inches of sand, and calculate all those materials. So it's just a little different approach to what we're doing. We're sort of exercising some manual control over all of this finesse. Otherwise, you have to have things drawn on layers. So if you get a finished design from an engineer that you're trying to model, which in a lot of cases we do, then a lot of that is not real. You're not building all this stuff. You're taking their stuff they've already built.
Yeah.
Problem is when you get it in from an engineer, you often get a flat 2D zero elevation PDF file. And so you have to elevate this stuff. And that's what we're going to take a look at tomorrow, and what are those elevating tools that we can use to quickly bring a flat 2D file where we can start to model. And then you can either do it like we've been doing it, which is my recommendation, especially since you're not using the takeoff tools, and you got the civil stuff. So we're going to do a lot of this 2D to 3D and setting contour elevations and all that kind of stuff. All right.
Sounds good.
Okie doke. Well, we'll put a bookmark in it for today, and we'll start back, same bat channel, same bat time.
Do you have to, are you going to send me another Zoom?
Yes. Yes, I'll send you a new link. In fact, as soon as we're done here in a little bit, I'll go ahead and send it, and I'll repeat it in the morning. So you have it. It's just, it'll be a new link for a new session. And then when we're done with all this, and it'll take a little while to process, but I'll have the videos and I'll give you links to those where you can get them off my YouTube channel and
Perfect.
all that. So, and you'll also, now, are you a PE or PLS or anything like that? Do you need continuing education credit hours?
No.
Okay, I mean, you get them anyway, and you'll get a certificate, but
Yeah, it'd be good to have to give to the boss so they have something that we got out of it. You know what I mean?
oh yeah. So
We like to see trophies.
there you go.